Imagine if we could bring water from other space bodies in our solar system to Earth. We know that each planet and even moons in our system have their own unique flavor of water. So what would happen if we drained them all? Let's see. First up, we have Mars. The red planet might not have beach resorts like Earth, but it's got something special – frozen water. Up at the tippy top and down at the bottom of Mars, there are these awesome icy hats called polar ice caps. The northern cap is made of water and carbon dioxide. The southern cap is a bit fancier because it's mostly made of water ice. If Mars had its own polar bears, they would feel right at home there. In the winter, it gets even bigger as more stuff freezes onto it. And during Mars's summertime, these ice caps get a bit smaller, with some ice turning into gas. And don't forget about the frozen water hiding in the ground. Mars might look all rocky and dusty, but it's also got pockets of frozen water beneath the surface. So what if we took all this frozen Martian water and poured it onto Earth? Well, there would be some twists. Martian water is a bit different from Earth's. It has extra deuterium ice cubes inside. Deuterium is a cousin of regular hydrogen. It's a bit heavier and has an extra little buddy in its nucleus. And here's the thing. Earth life, including plants, animals, and aquatic critters, has evolved to love our hydrogen-rich water. Martian water's extra deuterium might be like giving them a different kind of drink they're not used to. Plants might change and start behaving in unexpected ways, as well as animals and fish. Plants might find Martian water a bit heavy to sip, like drinking a super thick milkshake instead of a refreshing smoothie. Some might grow taller and stronger, while others might need a bit of time to get used to the new taste. As for animals, things get a bit more mysterious here. The effects would vary and depend on many factors. They might start behaving differently, eating different things in different amounts, becoming less or more energetic, and so on. High deuterium water might also influence the growth and development of animals, and they could catch many different infections and diseases. Same for fish and aquatic life. The metabolic processes of fish might change a lot, maybe even slow down or be less efficient. They could also catch a lot of health issues and imbalance. Possibly, the entire ecosystem would have to adjust to the new water. It's hard to say for sure, since we never tested anything like that, but it wouldn't be very pleasant for fish. Introducing Martian water on Earth would be a huge experiment. Our Earth is a delicate dance of ecosystems, so it would be like throwing a ball into a well-organized anthill. But Mars isn't the only celestial body in our solar system that has water. We also found some on the planet's moons. For example, on Europa, one of Jupiter's many satellites. Europa might look like a plain old ice ball on the outside, but underneath that icy crust, there's a hidden ocean that's more mysterious than a treasure map. But this ocean wouldn't be your ordinary swim spot. It's super cold, covered with lots of ice. However, even though it's freezing, scientists believe it might be able to stay liquid because of something called tidal heating. Tidal heating is what happens when one object in space gets all cuddly with another object. For example, if the moon is hanging out around a planet, the planet's gravity pulls on the moon, making it stretch and squish a little bit. And that's where the heat comes from. When you stretch and squish like that, it takes a bit of effort. It creates friction and heat inside the moon. And that's why the ocean itself doesn't turn into a gigantic ice block. In our case, it's because Europa is getting tugged and pulled by Jupiter with its enormous gravity. What's even more exciting is that this ocean could be a place for extraterrestrial life to hang out. We know that there are some bacteria that don't care about all these crazy temperatures. So, if there's water, there might be some life. But that's just a possibility. Another moon with a cold ocean is Enceladus, one of Saturn's satellites. This little moon is impressive. It got a dazzling icy outfit that reflects sunlight like a space disco ball. Now, imagine you're walking on Enceladus, and suddenly, whoosh! Water vapors shoot out of the ground like a geyser at a water park. These icy geysers are like nature's super soakers, and they're shooting water and ice crystals way up high into space. Some of them make a beautiful ring around Saturn called the E-ring, like a shiny bracelet made of frozen water. And we found more than 100 of them on Enceladus. You might be wondering, where's all this water coming from? Well, just like with Europa, beneath Enceladus's icy crust, there's a hidden ocean. This ocean is so deep that you could stack a bunch of skyscrapers on top of each other and it still wouldn't reach the bottom. Anyway, let's go back to our wild idea, bringing water from the secret oceans of Europa and Enceladus right here to Earth. If we did that, we would create some chaos. These extraterrestrial waters have their own unique flavors incompatible with our oceans. Europa's ocean water could be a bit salty with extra minerals, like a fancy spa water that's great for your skin. Enceladus's geyser water could be super sparkly, with some salt as well. That doesn't sound too bad, right? However, we're still not sure what else might be in that water. So, just like with Martian water, our marine life might start doing the water cha-cha with these new ingredients. Some species might find the new waters extra tasty and thrive, while others could have a much less pleasant time. Before we know the effects for sure, we need to study both moons in more detail. But all these celestial bodies have Earth-like water. What about, for example, another Saturn moon, Titan? Titan is a whole new world of seas and lakes, but not the kind you'd find on Earth. These lakes are filled with ethane and methane. They're made of hydrocarbons, like the stuff in your car's gas tank. Yes, exactly. These lakes are precious pools of fuel. And Titan's got way more of this fuel than Earth has oil and gas combined. They could also have a pinch of propane, and even a sprinkle of other things like hydrogen cyanide. Not a cocktail you'd want to drink. And they're also incredibly cold. Rain made of ethylene may erode the land and create underground caves. Oh, and Titan's lakes could have bubbles. It's like bubbles in your drink, but on a whole moon-sized level. These bubbles might be filled with nitrogen gas, and they could burst out like fireworks in the lakes. And when the bubbles pop, they might shape Titan's river deltas. As you can imagine, it's not the best liquid to bring to Earth. Our lakes and oceans would turn into exotic pools of hydrocarbons. Imagine lakes that don't ripple like water, but instead shimmer like liquid fuel. We'd have to find ways to adapt to this completely unfamiliar environment. Also, the hydrocarbons in Titan's lakes could solidify and turn into ice under Earth's different conditions. Imagine seeing chunks of icebergs floating on what used to be our oceans. Our boats might have to be redesigned to navigate through these icebergs. Also, rain wouldn't be water, and the winds would be much stronger than we're used to. Our cities, buildings, and infrastructure might have a tough time dealing with these extreme conditions. Not to mention the fact that this entire operation would really disrupt our ecosystems. What would happen to them is very unpredictable, but it wouldn't be good. We must remember, Earth's been perfecting its water mix for billions of years. Playing around with that mix could be like playing with a volcano. So let's appreciate and treasure our perfect Earth with its perfect water. I'll drink to that.
Earth was born dry. It's hard to imagine now, when literally every living thing is made from water. But even though we started as just a scorched, lifeless rock, it turns out water on our planet was literally inevitable. And not just on Earth. Water is inevitable almost everywhere. For decades, scientists believed that it was an accident. Earth's water came from somewhere else. They believed it was accidentally delivered by icy comets and asteroids showering our planet. This theory is a bit weird, because it relies on random cosmic collisions. Somehow, asteroids and comets just happen to hit Earth in the right way at the right time and in the right amounts. But there's no way it could form right here in the solar system. Earth formed way too close to the Sun to hold on to any water, right? Nope. Recently, this team of scientists from the Paris Observatory has proposed a new theory. They used data from the ALMA, a super powerful collection of 66 antennas that act like one. And they noticed something strange, a young star called HL Tauri. HL Tauri is essentially a newborn in stellar terms, being less than 100,000 years old. Plus, it's not very distant, situated just about 450 light-years away from us. Astronomically speaking, that's akin to having a neighbor across town. And this star has water surrounding it. It's right inside its protoplanetary disk. The protoplanetary disk is like a giant pancake of gas, dust, and ice that forms around a young star right after it's born. The star is in the center of the system, like the egg yolk, and the protoplanetary disk surrounds it like the egg white. And there it was, tons of water vapor. In fact, ALMA showed at least 3.7 times as much water vapor around this star as in all of Earth's oceans. And this wasn't the only discovery like that. They also studied a young star called V883 Orionis. This one is farther than HL Tauri, about 1,300 light-years away. And there it was too, water vapor swirling in its protoplanetary disk. And then, in another system called PDS 70, makes you wonder just how many star systems with water are out there. And most importantly, how did it get there? Water should be delivered on planets by asteroids, but there were no signs of icy asteroids crashing into the dust, no wild impacts to explain it. It seemed like the water was woven into the disk itself. This discovery changed everything. After deeper study, they finally realized how many planets end up with water on them, including our Earth. So, here's an updated story. Water was here long before Earth existed. In fact, it was here even before the Sun was born. It existed in a huge cloud of gas and dust called a molecular cloud. It's like space fog, filled with all kinds of particles. These clouds are nurseries for stars and planets. They're full of stuff that would eventually give birth to our Sun. In some super chilly and crowded parts of these molecular clouds, the water existed in the form of teeny tiny ice crystals. These crystals were sticking to random dust particles. Gravity was doing its thing by pulling things to each other. It started sticking dust and rocks together like glue. These rocks already had frosty sprinkles on them. As the region was spinning faster and heating up, it eventually gave birth to our Sun. This happened about 4.6 billion years ago, and the Sun was surrounded with the protoplanetary disk we mentioned. Gas, rock, and some ice that coated all these things. All the stuff that would become the planets. Our Earth started forming there too. It's about 4.5 billion years old, just a little bit younger than the Sun. At that time, it was still impossibly hot and dry, because it hung out super close to our young star. After about 5 million years, the newborn Sun was growing stronger and hotter. The gas and dust began to disperse, and with it, something else happened. The icy rocks in the protoplanetary disk started to heat up. Slowly, their frozen surfaces turned into steam, and now there were billions of these asteroids around the Sun, all releasing vapor into space. All that created an enormous, invisible halo of steam stretching across the solar system. The Earth began to move through this mist of water, also drinking it as it went. It soaked up all that vapor like a sponge. It gathered in lowlands, filled up craters, and seeped into the ground. Tiny puddles turned into lakes, and those lakes grew into oceans. From these oceans, life emerged. Now it covers nearly 70% of the planet's surface. So, it wasn't luck at all. Water was written into Earth's story from the very beginning. But the most incredible part is that, of course, this wasn't just an Earth story. If this process happened here, then it could be happening on other planets as well. That means it repeated on Mars, on Venus, and could potentially happen on tons of other planets out there. And this explains so much. Mars used to hold water, perhaps entire oceans, millions of years ago. Venus was a green, Earth-like paradise before the Sun pierced through its atmosphere and turned it into a nightmare. And even if water is gone from these places, it still exists on various moons in our solar system, including ours. Well, not really water the way we know it. When Neil Armstrong and his crew landed, there weren't any puddles in sight. That's because on the moon, it's not in liquid form, and not even ice. Instead, it's hidden as individual H2O molecules, scattered everywhere, mixed with dust and rocks. We're actually planning to collect it, not as individual molecules, of course, but by heating it up and turning it into actual drinkable water. And it also showed there might be more water deep underground on the moon, hidden in caves. Some of it is actually lakes, and who knows? Less radiation, more heat, actual water. Maybe we'll even find some microorganisms there one day. All that means we could actually build moon stations in the future. And not just on our moon, too. For a long time, Saturn's moon Enceladus was just a bright, icy dot in the night sky for us. We thought of it as a small, frozen world with the surface so reflective it outshone everything else in the solar system. It was beautiful, sure, but no one thought it was particularly special. That is, until Cassini decided to check it out. Instruments on Cassini detected that something was pushing against Saturn's magnetic field near Enceladus. That meant there was gas, maybe even an atmosphere, coming from the moon. When Cassini took a closer look, they were shocked to see that Enceladus was brimming with activity. Cracks near the moon's south pole, later nicknamed tiger stripes, were spewing huge jets of water vapor and ice particles into space. These geysers are like shot material hundreds of miles high. Where in the world was all this water coming from? Turns out, beneath the ice, hidden under a shell of up to 25 miles thick, is a huge ocean. A salty, liquid sea covering the entire moon. We later discovered that there might be a similar underground ocean on Jupiter's moon, Europa. Water is a key ingredient for life as we know it, which is why scientists are always searching for it beyond our planet. Finding water around other stars means those places could potentially support life. Could something be alive down there on these moons? We don't know yet. But one day, a new spacecraft will return and maybe even land on these moons. Whatever it is that we'll find there, it will be a great discovery. Most importantly, these moons could be great for us to build space stations on in the future. So, this discovery doesn't just change our understanding of Earth's past, it opens a door to something much bigger. It means that water could be literally everywhere. Therefore, life can too. We just need to have some patience and find it.
Now, you might want to book your dream vacation to Miami Beach as soon as you can, because this whole area might be underwater in the next 75 years. But it's not just Florida. Parts of Louisiana, California, and Washington are also expected to be among the first American states affected by sea level rise. If you live in the United States, you can check for yourself whether your address is on the list of cities that will disappear. Just search for Sea Level Rise Viewer on Google. That will take you to a tool created by the National Oceanic and Atmospheric Administration. And it helps us visualize what coastal flooding might look like in the future. Now, you see that dark area in blue? Those are the sinking cities of the U.S. And by that, I mean cities that could be submerged by 2100. That's in the worst-case scenario, if ocean levels were to rise by as much as 10 feet. Hopefully, it won't come to that. As you probably know by now, sea levels are going up because the Earth is getting warmer. When the planet heats up, ice at the North and South poles melts, and all that extra water flows into the oceans. Plus, warmer water expands and takes up more space. So, between the melting ice and the expanding oceans, sea levels slowly rise over time, and that means more flooding and even the possibility of some cities ending up underwater. Right now, statistics show that sea levels are expected to rise by around 6 feet by the year 2100. The problem is that this could cause major coastal flooding, and not just during storms or heavy rains. Even on clear days, some areas could end up underwater. And that brings us to a question. How do we actually know how high ocean waters are? These days, experts can measure sea level with incredible accuracy, thanks to satellite altimeters. That's basically a special type of radar that measures how high something is. It figures out the height of the ocean by timing how long it takes for a radar pulse to travel from the satellite down to the surface of the sea and then bounce back. When scientists combine that data with the satellite's exact location, they can map even the tiniest changes in sea level all over the world. Right now, coastal flooding predictions are showing us something serious. The rate of global sea level rise has doubled over the past 3 decades. And there are plenty of tools online that help us to visualize just how big this problem could become in the future. The Sea Level Rise Viewer I mentioned earlier focuses on areas within the United States. But if you don't live there, you can still check if your address might be in danger. Just look up the interactive map from Climate Central. If you set the water level to 10 feet above the high tide line, you'll see that a lot of countries could be seriously affected. Let's take a look at South America. In Argentina, for example, rising waters could flood many parts of Buenos Aires province. Head over to Brazil, and you'll see that a lot of cities, including Rio de Janeiro, would be affected. We might have to say goodbye to that iconic wave-patterned sidewalk along Copacabana Beach, and both of the city's airports would be flooded too. Things don't look much better in Europe. Major cities like Lisbon in Portugal, Valencia in Spain, and Rome in Italy could end up partly underwater. Honestly, the worst situation in Europe is probably in the Netherlands. Right now, about a quarter of the country is literally below sea level, and nearly half of it sits just 3 feet above. So if sea levels rise, they are facing some serious risks. This entire red zone, which includes cities like Amsterdam and Rotterdam, would be below the surface if the ocean rose by 10 feet. Fortunately, the Netherlands is probably the country with the most experience in fighting back against the sea. For years, they have tackled the threat with massive infrastructure, things like giant canals, windmills, and dikes, all designed to manage the water. And thanks to their efforts, the Dutch have reclaimed about 20% of their land from the sea. That's right, they're actually expanding. Unfortunately, some countries are at much higher risk than others. According to estimates, about 5 of them are in serious danger of disappearing in the near future. First up is Fiji, a tropical paradise loved by tourists. This nation is in a tough spot because of its low-lying landscape. There, extreme warming could cause sea levels to rise by as much as 6 feet by the year 2100. It doesn't help the fact that Fiji sits right in the middle of the Pacific Ocean, where massive storms can quickly turn things into chaos. That means people there need to brace themselves for more frequent flooding, and they're already taking action. To protect against coastal erosion, some communities are lining the seashore with old tires to keep sand from washing away in stronger waves. Others are planting mangroves across the coast. These trees can reduce the height of waves hitting the shore by an average of 31%. Plus, they help cut down wind speeds, which really matters during cyclones. Next on the red list is Vanuatu. This chain of islands, located between Australia and Fiji, could be underwater sooner than we think, and they're already making changes. Vanuatu was one of the first Pacific nations to relocate an entire community to safer ground. Back in 2005, people living in vulnerable areas on the North Island of Tegua moved to higher land. With temperatures continuing to rise, they're bracing for even more intense tropical cyclones. That means heavier rainfall, more flooding, and a much higher risk to both homes and infrastructure. The Marshall Islands are also facing a serious risk. This country is home to around 39,000 people and lives on the opposite side of the world from the United Kingdom. It's an extremely low-lying island nation built on what's basically a coral reef. According to NASA, sea levels there have risen by almost 4 inches over the past 30 years, and they could rise by about 7.5 inches over the next 30. And that's no small thing. If nothing is done, the islands could face more than 100 days of flooding every year by the end of the century. People over there are afraid of losing their homes. Studies also show that up to 40% of the buildings in the capital city, Majuro, could end up underwater in the future. But this country isn't ready to give up, and they're reinforcing the infrastructure. The Solomon Islands are also being slowly swallowed by the sea. This region has been experiencing sea level rise at nearly 3 times the global average. Over the years, satellite images have shown that 5 vegetated reef islands have already vanished beneath the waves. On the bright side, the people there are working hard to protect their homes. They're building stone walls along the coast and planting mangroves to hold back the water. But the worst case might be Tuvalu. as it could become the first country to turn completely uninhabitable because of rising seas. This island chain, located about halfway between Australia and Hawaii, sits only about 9 feet above sea level. And in its narrowest spot, in a place called Fungafale, the land is just about 65 feet wide. You can see how vulnerable the situation is, right? I mean, even before the higher tides arrive, the country's limited farmland could be affected by salt water. These islands are a powerful example of resilience, and a reminder that sinking cities don't have to mean disappearing ones. While the challenges are real, the global response to sea level rise is growing stronger every day. Around the world, communities are adapting, innovating, and coming together to tackle the threat of rising water. Being afraid of the ocean is a very understandable fear. We have it in our genes. In the past, humans had to avoid certain dangerous situations, like big animals and deep bodies of water, in order to survive. Plus, we've only explored 5% of the oceans, so we never know what we can stumble upon there. In regular conditions, GoPro is just a camera. But if you find it lying at the bottom of a 400-foot pit in the middle of the Caribbean Sea, that will make your blood run cold. I know 400 feet may not seem like much, but a person who is deep diving for fun usually can swim from 59 to 98 feet deep only, unless they're a professional diver. But say you made it to that pit and retrieved that GoPro. That would have still been fatal to you. In this specific hole where the camera was found, there would be a layer of hydrogen sulfide, a very dangerous and foul-smelling gas, at the mark of 300 feet. The gadget was 100 feet lower, alongside its owners, 2 long-lost explorers. To this day, very few people manage to dive this deep and go back unscraped. In fact, the deceased explorers were found only with the help of submarines. Now, you might be curious about the content of the GoPro. In stories like this, we expect proof of foul play or sinister footage. But the only thing found there were the images of happy times the explorers had during their trip. A sad ending to a vacay. Now, in deep waters, you can also find many species that seem to be otherworldly, but in a cute and interesting way, like the alien sponge. This fun little fella is a sponge first seen near the Mariana Trench in 2016. It's actually part of an ecosystem dubbed Forest of the Weird. Okay, this makes it sound a bit creepy. And what adds to the weirdness is the fact that the alien sponge had 2 little holes that resemble little eyes, so like it's peeking at you. Ah, another fun fact? The skeleton of this type of sponge is made of glass. And if you're afraid of cockroaches, I'll let you take a deep breath here. Ready? Cool. Because on the ocean floor, there are more than 20 different types of giant isopods, beetle lookalikes, that can be as big as 14 inches. Yikes! But fear not, these guys usually roam the ocean floor for food. So, unless you dive 7,000 feet, which we've just seen is not possible, you won't run into them. Now, despite the horror movie name, the bloody belly comb jelly is actually a fascinating creature you can also find in the ocean. They live in the twilight zone of the ocean, which is between 820 and 4,900 feet below sea level. Pretty far from where you usually soak your feet. But what's so cool about this jelly is its color. Because in the twilight zone, the light is very scarce. Many animals either emit a faint glow, like the anglerfish, or create a camouflage. The jelly here is blood red because, in the pitch-black darkness of the ocean, other animals won't see it digesting colorful bioluminescent prey inside its stomach. Besides, the jelly has a row of combs that spark a very beautiful iridescent light. Beautiful and lethal. Humans also have their fair share of contribution to the weird fest that is the ocean floor. Depending on where you swim, you might just find parts of rocket engines used during the Apollo program. Now, when a rocket is launched into space, parts of it are dropped into the ocean where it runs out of propellant, making the rocket itself lighter. And a part of the Apollo 11 rocket engine, yes, that one that first took humans to land on the moon, was actually recovered from the ocean after more than 4 decades. and you can see it at the Museum of Flight in Seattle. Not a space fan? Well, there's something for the Oregon Trail lovers too. There are 2 locomotives living their best lives, or worst, depending on your point of view, just off the coast of New Jersey. They're from the 1850s and are sitting under 90 feet of water. They probably fell off of a transportation ship during a rough storm, or were intentionally pushed over the barge so that the ship didn't sink. Most of these things can only be seen while diving, but worry not. Even if you have a lingering fear of the deep ocean, you can still find weird things by simply walking on the beach. Look at these bizarre Garfield landline phones washed away in Brittany, France. The French have been having bizarre encounters with the sarcastic orange cat since the 80s, and it took about 30 years for French farmer René Morvan to come forward with a simple explanation. A shipping container with Garfield merchandise got stranded in the sea, only to find its final resting place in a sea cave. We bet Brittany locals are still haunted by the creepy smile of that landline phone. And just like a storm uncovered the Garfield secret stash, it also moved a few ships that sank more than 600 years ago. But this is not a simple Titanic story. It actually sounds more like Pirates of the Caribbean, because when the storm moved those old ships, authorities from Caesarea found 2,000 gold coins, some silver and bronze coins, gemstones, and rings. It was a bigger treasure than a dragon could hoard. But don't get your hopes up. Even though most of the underwater archaeological zones in this region are open to divers, these treasures are safely tucked away in a museum. Speaking of pirates, and I was, another weird thing you can find chillin' in the ocean is the pirate city of Port Royal, Jamaica. In 1692, the city was devastated by an earthquake, followed by a tsunami. A really bad twofer. But the good news is, you can still visit it today, well, scuba diving, that is. This is actually not the only sunken city in the world. There's also Thonis Heracleion in Egypt, which is not at the bottom of the sea per se, but at the mouth of the Nile River. There's also Baiae, a Roman town built atop a supervolcano. Now, you might be thinking Baiae had the same fate as Pompeii, but guess what? The floor actually sank and the town went down with it. So, have you ever heard of underwater crop circles? Back in 1995, divers in Japan spotted perfectly round circles formed in the sand. They were 6 feet in diameter and looked like those crop circles from sci-fi movies. Scientists simply couldn't figure out what or who did it until they caught the culprit red-handed. A tiny male pufferfish, only 4 inches long. This little guy uses its body and fins to draw circles and squiggles and decorates his creation with seashells and corals. It takes the fish about a week to do so. All this hard work is part of a mating ritual, and if a female pufferfish likes the art, she will lay her eggs there, right in the center. The circular design of the underwater crop circle actually channels fresh water to the middle of the circle, the ideal scenario for the eggs to develop. And guess what? After she lays the eggs, the female pufferfish leaves, and it's the male that tends the eggs. But just in case fishes are not your thing, we can also offer you a cargo of rubber duckies, turtles, beavers, and frogs. 28,000 of them to be exact. These bath toys were traveling from China to the US, but much like our friend Garfield, were caught in a storm in 1992. From the North Pacific, our friendly duckies and beavers made their way to the UK by 2007. But some were bolder and traveled to Australia, Indonesia, Chile, Hawaii, and even Alaska. Now, have you ever seen a strange thing washed up by the beach? Let us know in the comments. Bye. If all the volcanoes on Earth suddenly erupted together, it'd be loud. We'd also have around 1,500 of these formations bursting at once. Now, normally it's just 10 to 20 volcanoes that are active each day. But what would the world look like if they all blew their tops simultaneously? Geologists think it wouldn't be pretty. Even if only the land volcanoes erupted together, it would set off a chain reaction way worse than anything we've ever seen before. The two big problems would be ash and volcanic gases. While the explosions in lava would be damaging for people nearby, the real danger lies in what happens next. A thick layer of ash would cover the planet, blocking out sunlight completely. No sunlight means no photosynthesis, which means crops would fade away and temperatures would drop considerably. And all this ash cloud could remain in our atmosphere for up to 10 years. Now, ash aside, there's also acid rain to worry about. Volcanic gases like hydrochloric acid and sulfur dioxide would mix with the atmosphere and fall back down as acid rain. This type of weather would harm the groundwater and ocean surfaces. Even if humans would find a way to survive up to this point, we'd have no corals and no other sea creatures around. Scientists have seen similar events in Earth's history at a smaller scale. Big volcanic eruptions have been linked to mass extinctions. When Mount Pinatubo erupted in 1991, it cooled parts of the world for 2 years. But the extra carbon dioxide from these eruptions could also heat the planet, the same way we turn our stoves to broil for that extra crispy layer on our casserole. Geologists also mentioned that there's evidence in our atmosphere that stuff like this may have happened in the distant past. During the Cretaceous period, carbon dioxide levels were way higher than today, which made it difficult for marine life to thrive. Who would survive all this? Probably just some extremophiles, these organisms that survive in harsh conditions like hot springs or deep undersea vents. As for humans, we could all lay low in underground bunkers until things clear up, or build multiple space stations that could fit us all. Yeah, right. The chances of all volcanoes erupting at once, though, are very slim. Whew! That's because there isn't one giant source supplying all the volcanoes on Earth. Each one of these openings has its own deposit of magma, except for a few cases where they indeed share the supply. For example, in 1912, Nova Rupta in Alaska erupted alongside another volcano sharing magma. Scientists have also found evidence of magma hiding under volcanic areas, like under the Taupau volcanic zone in New Zealand. This magma can spread out horizontally for long distances, but is still just a local feature. Even if we consider all the magma under Taupau as one system, it's not connected to other volcanic areas like Indonesia or the Philippines. Because the great majority are isolated, volcanoes can't sync up to erupt at once. The magma comes from different processes like mantle decompression or adding water to the mantle through subduction. There's no way to make all these different volcanoes erupt together because of how tectonics work. Now, that doesn't mean we won't see interesting volcano activity in the future. Take an underwater area near British Columbia, where recently about 200 small earthquakes per hour have been noted. Deep beneath the Pacific Ocean floor, off the coast of Vancouver Island, magma is set to erupt, heating the water so much that it'll bubble like soda. However, this event will likely go unnoticed by anyone other than scientists. The anticipated eruption will most likely happen around 3 miles below the ocean surface. Scientists explain that the earthquakes range from negative to 4.1 magnitude, meaning only those nearby would feel any tremors. This unusual activity gives us a rare opportunity to study how the Earth's crust forms. The magma beneath the ocean floor is estimated to be almost 1,500 degrees Fahrenheit, but will cool rapidly upon eruption and contact with water. This runny rock will solidify upon contact with the seafloor, turning black quickly. This event will be useful for biologists too, who will have the opportunity to study the marine animals' response to any changes, like run! Antarctica, often seen as a vast icy continent, also holds a volcanic surprise beneath its frozen surface. Researchers have identified over 130 under the western ice sheet alone, making it the largest volcanic region on Earth. Most of these volcanoes, about 90, were only recently discovered in 2017. But could any of these Antarctic volcanoes actually erupt? Well, it depends on which volcano we're talking about. While these formations are relatively young in geologic terms, it's hard for scientists to tell if they're still active or not. There are only two confirmed active volcanoes in Antarctica, Deception Island and Mount Erebus. The latter, standing tall as the highest peak on the continent, has been continuously erupting since at least 1972. It's known for emitting gas and steam, and sometimes even throwing out rocks in what are called strombolian eruptions. One of its most notable features is a persistent lava lake in its crater, a rare phenomenon due to specific conditions needed to keep the surface molten. For instance, it's fueled by a steady supply of magma from deep within the Earth's mantle. This continuous inflow of molten rock provides the material for the lava lake to exist. It also features low ambient temperatures. Despite its location in Antarctica, Erebus has relatively mild temperatures in its summit region because of the heat generated by the volcanic activity. This allows the lava lake to remain liquid rather than freezing over. Deception Island, another active volcano, last erupted in the 70s. While it's currently not showing signs of imminent eruption, it's being monitored closely for any concerning activity. Apart from these two being confirmed to be active, Antarctica is dotted with fumaroles, openings in the Earth's crust that release gases and vapors. Sometimes these fumaroles can create icy towers reaching heights of 10 feet. What we should focus on is maybe supervolcanoes. They're this type that has the potential to produce the most massive and destructive eruptions. Unlike the typical one, which has a single vent, supervolcanoes have a vast magma chamber beneath the surface, spanning tens or even hundreds of miles in diameter. Their eruptions can have catastrophic effects on the surrounding area and even impact global climate patterns because of the amounts of ash and gases they spill out into the atmosphere. One famous supervolcano is the Yellowstone one, which some say is gearing up for another eruption. It has the capacity to unleash a colossal eruption, spewing over 240 cubic miles of material. As much as we'd like to predict its behavior, volcanoes don't stick to a calendar. On the contrary, eruptions simply happen when there's enough magma beneath the surface. There also needs to be enough pressure for the magma to travel upwards. As far as we can measure, these conditions are not currently met at Yellowstone. Sure, many volcanoes operate on a cyclical pattern, but that doesn't mean Yellowstone is overdue. In fact, Yellowstone has had just 3 major eruptions over the past 2.1 million years. Also, the term supervolcano refers to the formation's size, not necessarily how fussy it is. Yellowstone's monitoring is extensive, tracking seismicity, ground deformation, thermal emissions, gas, water chemistry, and surface changes. Signs of an eruption would include thousands of earthquakes over a short period. We'd also see deformation on the ground and weird gas emissions ahead of time. Stable as it might look like for now, the consequences of it having a major eruption could look ugly. Ash dispersion could blanket a 500-mile radius, potentially disrupting Midwest agriculture and clogging waterways. Ash and gas emissions into the stratosphere could induce global climatic effects, making our planet colder for several years. And yes, we've seen some research that it shows there's more liquid molten rock under the Yellowstone volcano than scientists believe. But that doesn't translate to imminent danger.
Check out the cool map of New Orleans, USA. See those bold gray lines around the city? Those are levees keeping the city safe from the red flood coming in from Lake Maurepas, Lake Salvador, and Little Lake. Without those levees, New Orleans would be in big trouble with rising sea levels. Even with the levees, the damage looks pretty bad. The Biloxi and Jean Lafitte Wildlife Preserve look like they're almost underwater on the map. New Orleans is not the only city in the U.S. that's at risk of going underwater. The city of Savannah is located right in the middle of Hurricane Central. But even without Mother Nature's fury, the place is facing some serious sea level rise. The Savannah River to the north and the Ogeechee River to the south might both overflow into the surrounding marshland. And that's not even the worst part. By 2050, there may be massive floods every year that will make history books look boring. Sorry to break it to you, but Miami is on the line too. the Sunshine State is shelling out around $4 billion to stop things from getting worse, especially in Miami Beach, a hotspot for tourists. As of now, over 1,200 houses are at risk of flooding. The Big Apple is also getting hit with more and more crazy floods. In November 2021, they even had their first ever flash flood emergency. But still, the city is not ready for it at all. Even the Statue of Liberty, one of the most famous spots in NYC, got messed up in Hurricane Sandy. Now with sea levels rising, Lady Liberty is in danger once again. Tabasco, Mexico is no stranger to flooding, thanks to its coastal location on the Gulf of Mexico. This low, flat state is covered in wetlands and forests and already deals with seasonal floods. But with sea levels rising, it could eventually be completely taken over by water. This would put at risk some seriously important things, like the Mayan ruins of Malpasito and Comacalco and Tabasco sauce. The sauce comes from Louisiana. Jokes aside, it's not just Tabasco. Parts of the Yucatan Peninsula and Baja California are also at risk from rising sea levels. Panama City is also in trouble. Apparently, the super trendy Casco Viejo and the swanky Costa del Este hood might get submerged in 2050, when Pedro Arias de Avila first founded it. Fun fact, it was the first European settlement on the Pacific coast. The 17th and 18th century forts on the Caribbean side are also in danger. According to Climate Central, they might get washed away by rising sea levels. Even UNESCO has had them on its risk list since 2012. Some more sad news. The Bahamas is going to be hit hard by rising sea levels. I mean, Hurricane Dorian was already a huge bummer in 2019. And now, they're saying most of Grand Bahama, Nassau, Abaco, and Spanish Wells could go underwater by 2050 due to various reasons. Amsterdam. The Netherlands is one of the Low Countries for a reason. The city and its buddies Rotterdam and Den Haag sit low and close to the North Sea. You gotta hand it to the Dutch though. They know how to handle the water and keep it at bay with high-tech flood defenses. With sea levels constantly on the rise, it looks like their impressive system of dikes, dams, barriers, levees, and floodgates is gonna get even more crucial in the future. Still, despite all the effort, some experts are afraid that the Venice of the North might go underwater by 2030. Well, this one is not something you would expect, but still. Venice is sinking by 2 millimeters every year, and the sea levels are rising. This means that the city is getting flooded more often, and it's only going to get worse because of climate change. Just like New Orleans, Venice has a flood defense system. But as the crisis gets worse, it's gonna be harder and more expensive to keep it going. Even worse, beautiful St. Mark's Basilica has already been hit hard by flooding. They tried to introduce a flood barrier system, but even that didn't work out perfectly. In 2020, the flood barrier was not used and St. Mark's Square got majorly damaged. Looks like even when we try to prevent the effects of climate change, things don't always go according to plan. In London, rising sea levels are causing more flooding along the Thames estuary, and it's not looking good. Areas along the River Thames are especially at risk, putting iconic buildings like the Tower of London and the House of Parliament, as well as cultural hotspots like the Tate Modern and Shakespeare's Globe in jeopardy. And the British Museum? It has so much precious stuff, even Gollum would be jealous. We just can't let it go underwater. During your next Euro trip, make sure to add Bruges in Belgium to your list. Chances are you won't see it if you skip it this time. The thing is, it's also in danger of getting flooded. Bruges is now a UNESCO World Heritage Site, so we really hope they can protect it from any potential floods. Plus, it has a lot of nice local specialties we don't want to lose. You may not know it, but Andalusia in Spain is home to Western Europe's oldest city, Cadiz. It's been around for over 3,000 years thanks to the Phoenicians. But unfortunately, climate change is putting it at risk. Rising sea levels might flood the city's cobbled stone center, beautiful tree-lined plazas, and historic sea fortifications. And it's not just Cadiz. Parts of Andalusia are in danger of flooding too. Well, seems like one more destination must be added to your bucket list. Ho Chi Minh City, and especially its eastern marshy districts, are at risk, just like all the other places mentioned before. And it looks like the whole city is going to have a tough time with the Mekong Delta. While the main part of the city probably won't be completely submerged by 2030, flooding and storms are definitely going to become a big problem. So, it turns out that Bangkok might be in some hot water due to global warming. Literally, a 2020 study says that Bangkok could be one of the cities most dramatically affected by rising sea levels. It's sitting pretty low at just 5 feet above sea level. And to make things even more interesting, it's sinking at a speedy rate of an inch per year. And the cherry on top? The soil it's built on is super dense clay, which means it's basically a flood magnet. By 2030, parts of Bangkok, including the main airport, might have to get used to living underwater. The next city at risk is Kolkata, India. The fertile land in West Bengal has been a major key to their success for ages, but now it's causing some big worries in Kolkata and the surrounding areas. Just like Ho Chi Minh City, they could have some serious problems with all that rain during monsoon season. And the map of what could happen in 2100 is pretty scary stuff. The next destination is Shanghai, China. It's literally translated as the city on the sea, but it might actually end up under the sea. Climate control data is flashing red warning lights for this megacity, making it one of China's most at-risk cities. The Yangtze Delta, where Shanghai sits, and the Pearl River Delta, home to the Guangzhou, are both in hot water too, with lots of people living on low-lying land that might get flooded. The Maldives, a luxurious group of islands, already get flooded every year. Experts think they might lose 80 or even more % of their islands in the next 30 years. The Maldivian authorities aren't taking any chances though. They're already making plans to buy land in other countries, just in case they need to relocate the whole population.
Breaking news! Turns out that potentially habitable planets aren't as rare as we thought. Scientists found out that they were wrong about how water appeared on Earth. So let's see what these new discoveries tell us about life in the universe. Water is essential for life, and scientists are always on the lookout for other habitable planets and stars with it. But did you know that Earth's water might have come from outer space? Recently, they took a sneak peek at a young star called V883 Orionis. This star is located about 1,300 light-years away from us, and they spotted something incredible: water vapor surrounding the star. Of course, they decided to study it, and that's when they realized that the composition of this water is remarkably similar to the one in our own solar system. This discovery, among many others, confirms that Earth's water was brought to us from space. But how exactly did it happen? And where did it originally come from? When a star is being born, it's surrounded by a big cloud made of gas and dust called a molecular cloud. It's like a cosmic fog. Inside this cloud, there are special things floating around, including water vapor. Now, where does this water vapor come from? Well, new water molecules could form in molecular clouds through some fancy chemical reactions. Most of the water vapor originates near the surface of the cloud, and that it doesn't extend into the cloud by more than about 1/100th of a light year, probably because it turns into ice. Now, in the really cold and crowded parts of these clouds, the water vapor can turn into ice and stick to tiny particles of dust. And together, these dust particles create something else: a special disk called a protoplanetary disk. This disk of gas and dust is like a cozy blanket surrounding the star. And it's made up of tons of little particles with ice on it. As the dust particles bump into each other and stick together, they come together and form bigger and bigger objects: comets, planets, and other celestial objects. And, of course, some of those pieces become comets and planets like the ones in our own solar system. V883 Orionis is like a fantastic laboratory for investigating this. Around this superstar, there's also a protoplanetary disk. Scientists had a feeling that when these young stars get really hot, they might release bursts of heat that can turn some of that frozen ice into water vapor. They wanted to investigate this exciting idea. To make sure they were right, they used a super powerful radio telescope called ALMA to look at V883 Oriones. And guess what they found? They detected water in the form of gas in that system. So the idea turned out to be correct. They also compared the amount of our regular water to the one found in that disk. The space water turned out to have a heavier form of hydrogen called deuterium. It was the first time we compared our water to an interstellar one. By doing this, the scientists were able to finally make connections between the water in that star, the comets in our solar system, and the one in the early stages of star formation. Okay, now we know where water comes from in the universe. It's formed when hydrogen and oxygen combine together in all sorts of cosmic clouds of dust and gas. And usually first it's ice. Although sometimes the hot breath of stars can melt it and turn into vapor. Anyway, these pieces of ice fall on particles of dust and rock. The little particles grow for a long time and form into comets, asteroids, and so on. And then these comets and asteroids spread water across the universe. But how did the water get to the Earth? Well, scientists used to think that it was brought to us by comets and asteroids. They crashed into our planet a lot and eventually brought a lot of water to it. But now that we learned more, they have a new theory. Now they believe that Earth, rather than relying on icy comets, greedily sucked up water from its surroundings. Around 4.5 billion years ago, when our sun was a young star, it was also surrounded by a protoplanetary disk. So, the process of forming water in our solar system worked just like we discussed before. In other words, we also had some icy particles within our solar system. And Earth, like a celestial sponge, absorbed these ice and vapor from its nearest surroundings. It quenched water from teeny tiny pebbles floating around. What a thirsty planet! And this entire process took just a few million years, not hundreds of millions of years like we previously thought. Why is it important? Because it changes our understanding of how life can form in the universe. We used to think that planets with water on them were super rare. We thought that they had water delivered on them through tons of collisions, that it should take hundreds of millions of years, that the planet should be super lucky, and so on. If that were the case, the chances of finding water on planets beyond our solar system would be very low. But we were wrong. To come up with this fascinating idea, the scientists looked at more than 60 space rocks and planets to understand their makeup. They focused on something called isotopes, which are different versions of elements. By studying the isotopes, they discovered how planets form and how long it takes. And that's how they found a close link between Earth and other rocky objects in our solar system. That's why they now believe that planets similar to our Earth, rocky ones, actually have a pretty big chance of having some water on them. Moreover, let's look at any star system with a star the size of our sun. If there's a planet orbiting this star and the distance isn't too far or too close, then this planet most likely contains some water. This groundbreaking theory has exciting implications for the search for life in space. Habitable planets around other stars could be more common than we ever imagined. But that's not all. There's another salty discovery about water. Scientists found itty-bitty grains of salt in an asteroid. These salt crystals are definitely from space and look just like the ones in your kitchen, only super tiny. The S-type asteroid called Itokawa came back to Earth on a spaceship called Hayabusa. It's shaped like a peanut and hangs out near Earth. It probably broke off from a bigger space object. This type of asteroid is usually thought to be dry, but little salt crystals could only have formed in the presence of liquid water. So this discovery is shaking things up and making us think that there might be more water in asteroids than we thought. Scientists think that frozen water and other substances gathered on the asteroid's surface, but then the heat from radioactive decay and many meteorites hitting the asteroid made it warm enough for the frozen water to turn into liquid. Imagine all that chemistry action happening on a space rock. Well, would you look at that? Another discovery that's challenging the idea that water could be brought to us only by something from beyond our solar system. Looks like even the ordinary asteroids closer to the sun could have water too. If you think about it, Many of our recent discoveries have hinted at this. For example, we know that there must have been water on Mars at some time. We also know that there probably were entire oceans on Venus a long time ago. And of course, even now in our solar system, there are lots of objects full of ice. So if there is plenty of this life elixir in our own solar system alone, it would be strange if there was no water anywhere else, wouldn't it? So let's hope that we've just unraveled a new chapter in our understanding of Earth's origins and expanded our hopes of finding other habitable worlds out there. Stay tuned for more discoveries!
The lost city of Atlantis may have actually been found. No, really. Two researchers were working in the waters off the coast of Cuba when they discovered the ruins of what looked like an ancient submerged city. That happened about 20 years ago, and yet no one really talks about it today. It's like the authorities just took the research, locked it away in some top-secret room, and decided no one else should know about it. But why? Well, I'm going to tell you. Back in 2001, Paulina Zalitsky, a marine engineer, and her husband, Paul Weinswig, were hired to explore the waters off Cuba's western coast. They had two main objectives: to search for old shipwrecks, possibly hiding treasures like gold and jewels, and to locate valuable oil and natural gas deposits deep underwater. They were using a sonar. Basically, this equipment is like a sound-based radar. It sends out sound waves underwater, and when those waves hit something, like a sunken ship, they bounce back. The system can figure out where and how far the object is just by listening to the echo. So, the couple was scanning the seafloor with this equipment more than 2,000 feet below the surface. And then, out of nowhere, they found something way more interesting than gold or oil. They found stones. Not just any stones. I'm talking huge, perfectly arranged stones. Kind of like a mini version of the pyramid at Chichen Itza, or even better, like a bunch of tiny submerged Chichen Itzas. Yep, they saw that, or at least they think they did. The thing is, sonar doesn't work like a camera. It definitely doesn't record video or take actual pictures underwater. What it does do is create images using sound. And those images are usually just outlines or shapes, kind of like a blurry black and white sketch. It shows you where things are, but not exactly what they look like. And that's exactly what happened back then. The equipment started producing images of these perfectly organized stone structures, and it really looked like some kind of urban development. I mean, the site was just too organized, too symmetrical to be just random rocks. But it sounded too good to be true. I mean, this discovery could totally change everything we know about ancient civilizations on the American continent. So the scientists decided it would be too irresponsible to announce anything without finding more evidence first. And that's why they decided to go back to that same spot. This time they sent down an underwater remotely operated vehicle to actually see what was going on beneath the sea. See? This robot was basically an underwater cameraman. And yep, it confirmed it. There was definitely something strange down there. It looked like an ancient city made of huge, smooth blocks of granite. These rocks were about 8 feet by 10 feet. Some were in pyramid shapes, others were circular. Some seemed to be deliberately cut and then stacked on top of each other, while others appeared isolated from the rest. Together, they looked like they were forming corridors and outlines of rooms. It was like finding large buildings in the middle of an underwater desert. These images were enough for Zalitsky to seal the deal. Back then, she confirmed that this amazing structure, her words, could have been a large urban center. Again, her words. Then the couple started to speculate. They said that these structures were probably built more than 6,000 years ago, which would make them older than the Great Pyramids of Egypt. It's even older than the famous Maya, the civilization that used to live in the Americas and is known for their ancient and advanced temples. The research also suggested that these structures might belong to a civilization that lived on the American continent thousands of years ago, and that we didn't even know about. This supposed civilization once thrived on a 100-mile land bridge connecting Cuba to Mexico's Yucatan Peninsula. But then, something catastrophic happened. According to their theory, the Earth's faults shifted beneath the surface, leading to a massive earthquake. Then, in the blink of an eye, the entire bridge was destroyed. The land was swallowed up by the sea and ended up at the bottom of the ocean, and this civilization disappeared. Of course, all the connections to the famous Atlantis myth got the media totally hooked on the story. News websites ran headlines like "Lost City of the Caribbean Found" and "Atlantis Found in Cuba." So, could that really be Atlantis? I mean, did they finally find the remains of this supposedly super advanced and lost civilization? Well, it's hard to say. From the start, part of the scientific community wasn't buying into the story too much. First, there's the issue of the date. Saying that this civilization existed at this spot at least 6,000 years ago just wasn't very credible. Then some European archaeologists argued that the stones they found using sonar might just be natural limestone, not perfectly sculpted granite. And third, it was too deep. Even with the whole theory of earth faults opening up and swallowing everything, it's still hard to explain how an entire city ended up so deep in the ocean. For comparison, there is Heraklion, a real ancient Egyptian port city that got submerged. Today, it is only about 19 feet underwater. But this so-called Atlantis city is at depths between 2,000 and 2,460 feet. See how that's totally different, right? People think it would have taken around 50,000 years for such stone structures to sink to the depth where they are said to be found. And according to experts, none of the known civilizations from that long ago had the ability to build such structures. But for Zalitsky, yes, it was possible. She still believed in the fault theory to explain how this land ended up at the bottom of the ocean so fast. Big movements of the Earth's tectonic plates are usually followed by things like volcanoes and earthquakes. So, according to her, it's a powerful event, and the island sinking could have happened really quickly. This earthquake theory could also explain why some of the megaliths on the seafloor look organized while others don't. But to really prove any of this, they needed a specially designed robot to go down there again and take samples of the rocks and sediment. That way, they could figure out how old the rocks were and maybe even find signs of human life, like carvings, sculptures, or artifacts. The problem is, drilling into those structures isn't easy. They look like granite, and drilling granite that deep underwater is seriously tough. And more than anything, they needed money to do it, a lot of it. So maybe they just never got the funding. Because even with all that initial hype, no further explorations or studies were ever reported. And that lack of follow-up sparked a lot of speculation. Some people even wondered if the story got shut down on purpose, like maybe the authorities wanted to keep something top secret. As if this underwater city was built by some kind of higher extraterrestrial being, and they just don't want us to find out. But truth be told, the strongest argument for saying, yeah, that is definitely a lost city, is that nature supposedly couldn't have built something so symmetrical. Geologists did try to find natural explanations, or at least similar examples from other parts of the world, but they came up short. Still, just because we haven't found a clear natural explanation doesn't mean there isn't one. Nature can create some pretty wild and unexpected stuff. So honestly, that whole too perfect to be natural angle is kind of a weak argument. What most likely happened is that experts just weren't convinced it was actually a sunken city. And that's probably why no one followed up on their work. Over time, the buzz faded, the story disappeared, and the site slipped back into silence. And without more data, the true nature of those underwater formations off Cuba's coast is still a mystery. Recently, scientists have made an astounding discovery that can change the entire course of Mars exploration. Apparently, there are oceans of liquid water on the red planet. So, the future looks bright. We could use this water to support future missions, and then even relocate to Mars since we wouldn't need to worry about where to get this precious liquid, right? Well, there's one big problem. These oceans of liquid water are in Mars, so deep inside that we aren't likely to get there. At least that's what a new analysis of seismic data collected by the Mars Insight lander claims. Huge reserves of liquid water seem to be the best explanation for some seismic quirks of the red planet. So all this precious water is out of our reach. But we need to find it to solve the puzzle of the aquatic history of our blushing, dusty neighbor. And the first thing we need to do is identify where the water is and how much of it the planet is hiding.
Navigation has confirmed that the parachute has deployed and we are seeing significant deceleration.
Now, our rovers are scurrying about on the surface of the red planet, gathering all the available data on the planet's surface geology. And it's getting increasingly obvious that Mars was once covered with water. Many factors, from Martian terrains to ancient dry lake beds and deltas, suggest that there was a time when the planet was quite soppy. These days, there's still some water on and right below the surface of Mars, but it's in the form of ice and nowhere near what Mars had in the ancient past. To understand how much of it could have been on the red planet billions of years ago, we must know where all this water went. There are two spots where the water could have gone: into space or toward the interior of Mars. Then it could have been isolated as either liquid reservoirs or ice deposits. Currently, we don't have any way of measuring how much water once leaked away. But now, we finally can find out more about the gooey center of the red planet. All thanks to the Mars InSight lander. It isn't operating anymore, but from November 2018 to December 2022, it was listening to the hums and rumbles and monitoring the activity below its feet. The thing is, acoustic waves generated by seismic activity deep inside the planet can change according to the composition and density of the material these waves are moving through. And scientists can get a lot of information analyzing the behavior of seismic waves. In this case, they used a model similar to those used to map underground oil fields and aquifers on our home planet. Then, with the help of this model, they analyzed the data gathered by InSight on Mars. They discovered that the best explanation could be that there was a layer of fractured rocks whose cracks were filled with water deep under the surface of the red planet. That layer could be at a depth of 7 to 12 miles. That's why it would be extremely tricky for future missions to get to it. And still, the new discovery could help us understand the Martian water cycle. Confirming the existence of a large reservoir of liquid water can help us sneak a peek at what the climate on Mars used to be or what it could be like one day. And if once Mars had a lot of water, it could have been habitable in the ancient past and might become habitable in the future. Water is crucial for life as we know it, so underground water reservoirs on the red planet could already be habitable. Maybe, while we're talking, tiny microorganisms or even some tentacled creatures are living their lives in the comfort of their underground home. On Earth, super deep mines do host life, and the bottom of the ocean, with its immense unbelievable pressures, isn't lifeless either. So far, we haven't found any evidence of life on Mars, but for now, it sounds like this place has the potential to sustain life. InSight data has shown that there isn't likely to be a lot of water ice in the upper crust of the planet, at least in the region around the lander. But if it turns out that there is a water-rich layer deep below the surface and stretching around the entire globe of the planet, then there would be enough water to fill ancient ocean beds and even more. Now, Mars isn't the only place outside Earth where there is water or where we might one day find water. Take the good old Moon, for example. On Earth's natural satellite, water can be found all over the surface, but it's not the water you might be imagining. On the Moon, water remains mostly as ice, and it's distributed unevenly. For example, the poles of the Moon are the regions that never receive sunlight. This is the reason they're extremely cold, and it's no wonder there's a lot of ice there. The ice in these areas is often mixed with the lunar soil and hiding deep below the surface. Then there's Enceladus, the sixth largest moon of Saturn. In reality, it's not that large, just 314 miles across. In other words, this moon is small enough to fit inside Arizona. Ooh, we should try that. Well, interestingly, when the Cassini space probe first arrived at Saturn, researchers were expecting Enceladus to be a frozen ball of ice. But what they saw was plumes of icy particles and water vapor erupting from geysers on the moon's surface. It was clear that there was a massive ocean between the moon's rocky core and its icy shell. Then there's Jupiter's moon Europa. Scientists think that this world is one of the most promising places in the solar system when it comes to searching for new life forms. That's because Europa has a huge saltwater ocean as deep as 40 to 100 miles. And even though it's under a layer of ice that is likely to be 10 to 20 miles thick, it's still potentially habitable. Astronomers believe that plumes of water might erupt from cracks in the ice shell and release the contents of the moon's ocean into space. The temperature, pressure, and chemistry are very different on Europa, and astronomers aren't sure yet how the ice behaves there. That's the main reason they haven't figured out yet how deep or large the water reservoirs on Europa are and how long they need to refreeze. But out of all the places where we could find water in the universe, the most bizarre is probably open space. In 2011, two teams of astronomers discovered a cloud of water floating freely among stars. It was the largest and farthest reservoir of water ever detected. So this massive cloud of water vapor surrounds a black hole. But not just any black hole. This one's a quasar, located 12 billion light-years from Earth. The conditions around this quasar must be really special to create such an enormous amount of water. This cloud contains 140 trillion times the volume of all the water on Earth. That's enough to give every person on the planet a whole planet's worth of water 20,000 times over. Sounds wild, doesn't it? But there's something even cooler. Astronomers think this water cloud formed just 1.6 billion years after the universe began. This discovery is yet another sign that water has been around all over the universe, even in its early days. But here's the kicker. Until they found this, scientists had never detected water vapor so far back in time. Sure, there's water in our Milky Way galaxy, but most of it's frozen solid in ice. This discovery really pushes the boundaries of what we know about water in the universe. At first, it may seem like the sun is burning, but it's actually not true, because the burning of our star isn't chemical combustion, it's nuclear fusion. The sun can't run out of oxygen or stop burning because it doesn't use oxygen to burn. Regular carbon combustion requires oxygen. As soon as there's no oxygen, the process of burning stops. Now imagine a candle. If you cover it, it doesn't have access to oxygen anymore, and the process of burning stops. But in nuclear fusion, the nuclei of atoms are fused together to make new, bigger nuclei. Such changes cause atoms to become new elements. Nuclear fusion doesn't require oxygen or any other material altogether. You just need enough pressure or heat to squeeze the nuclei of atoms close enough for them to overcome their electrostatic repulsion and bond into one nucleus. In 2027, two teams of astronomers discovered a cloud of water floating in open space. It was the largest and farthest reservoir of water ever detected in the universe. It's a cloud of water vapor surrounding a huge black hole called a quasar, 12 billion light-years away from Earth. The environment around the quasar must be unique to somehow produce such giant masses of water. It was formed by energy waves colliding hydrogen and oxygen atoms together. The cloud contains 140 trillion times the entire volume of water on our planet. It could provide each person on our planet with a planet's worth of water 20,000 times over. Wow! Even cooler, astronomers believe this water cloud appeared just 1.6 billion years later than the universe itself. Scientists consider it another demonstration that water exists throughout the universe and was present already during its early days. At the same time, before this discovery, scientists had never found water vapor present so far back in the early universe. There is water in our home Milky Way galaxy, but most of it is frozen in ice. Not only water is floating out there in space, alcohol too. In 2009, scientists were examining a massive cloud of gas and dust in the center of our galaxy when they stumbled upon a surprise. There was ethyl formate within the cloud. This chemical is responsible for the sweet flavor of raspberries. They also found one more cool region. This one was brimming with ethyl alcohol, the same type found in many beverages. At the North Pole of Saturn, a mysterious storm is raging. It's ginormous, spanning an area larger than our planet and showcasing a beautiful but baffling hexagonal pattern. No one has understood yet why the storm has such a bizarre shape. After the hexagon was first discovered in 1987, it remained hidden in darkness up to the moment when sunlight exposed it again. Soon afterward, the Cassini spacecraft, designed to explore the Saturn system, provided a series of captivating images and even a video of the hexagonal storm. It turned out to be colossal in size. Its estimated depth is around 180 miles, and the eye of the storm is 50 times as large as the typical storm on Earth. The storm is also changing its color from blue to gold. Winds of hydrogen and ammonia surround the storm and move at more than 300 miles per hour. The storm has several centers. Some of them move clockwise, and others follow a counterclockwise direction. The largest vortex appears to be white, and it's twice larger than the standard hurricane on our planet. As for the hexagon itself, it's a jet stream made up of atmospheric gases. Experts refer to it as just a current of air and weather features. But there is one intriguing detail: a vortex sitting at a higher altitude than Saturn's clouds. It looks like a large towering structure. Saturn's auroras, triggered by the planet's magnetic field, are located atop of the hexagon, giving its appearance a mystical vibe. Astronomers have found a giant, likely active volcano near Mars's equator. It was literally hiding in plain sight. It's ancient and deeply eroded, but seems to be still functioning. There may even be remnants of a glacier ice near its base. That's why this discovery might indicate a promising new location to search for life, as well as a potential destination for future human and robotic exploration. The structure is still awaiting its official name. At the moment, it's referred to as the Noctis volcano. It reaches a height of 29,600 feet and spans an impressive 280 miles across. Such a giant size indicates that the volcano has been active for a very long time. In its southeastern part, there's a thin, recent volcanic deposit, and beneath, glacier ice might still be present. At a distance of 700 million light-years away from Earth, there's a gaping hole, a blank void with no galaxies, stars, planets, or asteroids, literally nothing. The void is a roughly spherical region about 330 million light-years across. Our home Milky Way galaxy could fit there billions of times over. That's the mysterious Boötes void. It lies in the constellation of Boötes, the herdsman driving the plow around the North Pole. At first, this void had the name of the Great Nothing, but later it was given its current name. Now, we know that galaxies look like a giant web. Most of them are parts of long structures called filaments. Those wind through the cosmos, and when they meet, they form regions with a high concentration of galaxies. These regions are what we know as galaxy clusters, but between these clusters and threads, there are enormous empty voids that hardly contain any galaxies. Such voids actually make up almost 80% of the observable universe, and most of them are huge, from 30 to 300 million light-years wide. The Boötes void is one of the most massive ones. It has even earned the title of supervoid. Astronomers think it might be the result of a few smaller voids merging together. There is a diamond planet out there that orbits a star in the constellation of Cancer, completing one full rotation in a mere 18 Earth hours. The planet's scientific name is 55 Cancri e. The radius of this faraway world is twice as large as Earth's, and its mass is 8 times greater. The planet is scorching hot, the temperatures on the day side reaching almost 5,000 degrees Fahrenheit. But the coolest thing about 55 Cancri e is that, according to some specialists, at least a third of the planet's mass could be diamond. That's the equivalent of around 3 masses of our home planet. Sounds like big money floating out there in space. How about we calculate how much this planet could be worth? Wait, someone has already done it, and the number is astronomical. Pun intended, of course. It's 26.9 nonillion. And if you're confused by this number as I am, that's 26.9 followed by 30 zeros. Now, for comparison, one of the most expensive diamonds on Earth ever is the Culian. It costs a whopping $2 billion, and its original weight was a mind-boggling 3,106.75 carats. It was, and still is, the largest raw gem diamond ever found. Later it was cut into many small diamonds. The largest of them is Culian 1, which also goes by the name of Star of Africa. It has a carat weight of about 530, but imagine how much bigger and more expansive the Diamond Planet is. Nebulas are gigantic clouds of gas and dust, and some of them can have really unusual shapes, as if they were made this way on purpose. With time, gravity starts to pull these clumps of dust and gas together. They grow larger and larger, and their gravity gets more powerful. One day, this mass becomes so big that it collapses under its own gravity and forms new stars. Among some of the most beautiful nebulas out there, we must mention the Butterfly Nebula. Its wingspan is more than 3 light-years, and the structure inside the nebula is one of the most complicated ever observed. The central star, a white dwarf, is heated to an incredible 450,000 degrees Fahrenheit. It means it formed from a giant gargantuan star, likely more than 5 times the size of our Sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. It's what probably makes the whole structure look like an hourglass or a butterfly. The Ring Nebula looks like a giant cloud of dust and gas surrounding an old, almost extinguished star. At first sight, it does look like a ring, but astronomers say the nebula isn't a bagel, it's a jelly-filled donut. They must be hungry. The deep space colorful object, more than 2,000 light-years away from Earth, is actually a ring that wraps around a blue ball-shaped structure. Each end of the structure sticks out of the ring's opposite sides. The pillars of creation look like something out of this world. See for yourself. They're located 7,000 light-years away from Earth in the Eagle Nebula. That's a young cluster of stars just 5.5 million years old. On a space scale, they're just babies. Once, the Hubble Space Telescope managed to take an image of several dark silhouettes near the nebula's center. And now you can see them with your own eyes. Those are the so-called pillars of creation, an active star-forming region. Look at this famous image. The blue colors represent oxygen, red is sulfur, and green means the presence of both hydrogen and nitrogen. The pillars are also bathed in the ultraviolet light coming from a nearby cluster of young stars. Unfortunately, the winds from those stars are slowly but steadily eroding the magnificent towers of gas and dust. Far out in space, a ghostly super-ancient galaxy is floating all alone. It shines with a faint glimmer of starlight and has hardly changed for billions of years. Astronomers have no idea why it's there or how it formed. Meet DGSATI, a living fossil galaxy. It's as big as the Milky Way, but is nearly invisible because its stars are spread out incredibly thinly. But what makes the galaxy so unique is that it's sitting all alone, unlike other galaxies of this kind, which are usually found in clusters. It might mean that DGSATI was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, the galaxy is a real living fossil. Astronomers have discovered the most massive stellar black hole ever spotted in our home Milky Way galaxy. This newly found space monster is 33 times bigger than the Sun and sits 2,000 light-years away from us. Until recently, the largest stellar black hole found residing in our galaxy has been around 20 times as big as our star in terms of mass. As for the average stellar mass black hole, it's usually about 10 times as hefty as the Sun. Scientists spotted the giant black hole after a star started to wobble while orbiting in that area. The black hole got the name of Gaia BH3. The proximity of this space object to Earth makes it the second closest to our planet black hole ever discovered. The nearest one is called Gaia BH1. Makes sense? It's hanging out around 1,560 light-years away from us. This uncomfortably close neighbor has a mass of around 9.6 times that of the Sun. That means it's way smaller than the newly found black hole. Gaia BH3 is located in the Aquila constellation. From Earth, it seems to have the shape of an eagle. Interestingly, astronomers didn't expect to find a high-mass black hole lurking so relatively close to Earth and remaining undetected for so long. Now look at this marvelous exoplanet. It resembles a giant eyeball hanging out there in space. But it isn't the coolest thing about it. This distant world, identified in 2017, is one of the most promising places for finding life outside our solar system. The exoplanet is called LHS 1140b, and it shows signs of having a global ocean capped in ice. It's that very iris, a huge region around 2,500 miles across, which is constantly gazing at its host star. The planet has a radius of about 1.73 times the radius of Earth, and is 5.6 times as massive as our home planet. The giant eyeball planet orbits much more closely to its star than Earth does. It needs just around 25 days to complete an entire orbit. If the star were similar to our Sun, such a distance would definitely be too close for life to appear on the planet. But instead, it's a cool and dim red dwarf. That's why the exoplanet lies in the habitable zone of its star, where it's not so cold that all surface water would freeze, and not so close that this water would steam away. At the moment, LHS 1140b looks like the most promising candidate for hosting life in our planetary neighborhood. Solar flares are extremely powerful bursts of electromagnetic radiation that can last from minutes to hours. They occur when there's some magnetic disturbance in the Sun. Then, magnetic field lines in the atmosphere of our star get tangled and snap. This releases giant amounts of excess energy, including ultraviolet radiation and intense X-rays. These twisted lines appear in sunspots. Those are darker and cooler regions on the surface of the Sun. They form when magnetic fields that used to hide deep within our star rise up to the surface. As for coronal mass ejections, or CMEs, which are launched by solar flares, they're sent outward into space. They hit planets, satellites, and basically any objects in their path. Those that come across Earth trigger geomagnetic storms, which in most cases result not only in beautiful auroras, but also in power grid failures and satellite malfunctions. All these extreme solar phenomena, CMEs, sunspots, and solar flares, get much more intense during the peak of the Sun's 11-year-long activity cycle. It's known as solar maximum. Right before this event, the Sun steps up its activity. It starts to spit out giant blobs of fiery plasma, emits powerful streams of radiation, and grows planet-sized spots. At first, experts were sure that the current solar cycle would reach its peak in 2025. But judging by recent numerous sunspots, intense solar storms, and some other rare solar phenomena, solar maximum is likely to arrive sooner than that. This planet is as light as a piece of fluff stuck to your jacket. In the scientific world, its name is WASP 193b, but we'll call it the Cotton Candy Planet. It's located around 1,200 light-years from us. We'll never see it with our own eyes, but scientists say the Cotton Candy Planet is pretty much Jupiter's bigger, bouncier cousin. It has an extremely low density. Combined with other factors, like its high temperature and the infrared brightness of its host star, it makes it special. Interestingly, the planet's radius is just 1.46 times the radius of Jupiter, but its mass is a mere 0.139 times of our gas giant. May I have a close-up here, please? Thank you. See how fluffy it is? It would be absolutely impossible to stand on its surface should you ever reach this distant world. It's not often that you can meet something like WASP 193b at a planetary party. Such planets are rare. Their fluffiness might be caused by their planet stars. Those heat them, puffing them up like a marshmallow that's seen too much campfire action. The planet's super low density makes it a real anomaly among those 5,000 plus exoplanets we have already discovered.
Hey, don't freak out. Those red waters you see aren't blood oceans. It's just a natural occurrence called the red tide. Red tides often happen in Florida, especially in the West Florida shelf, and they can stick around for weeks or even months. They're basically caused by an increase in algae levels, hence the color. Those algae produce toxins that can be harmful to marine life. They can also be bad news for us humans, causing symptoms like upset stomach and urgent bathroom trips, if you're picking up what I'm putting down. Volcanoes are super scary, but there's nothing scarier than getting taken out by a pyroclastic flow. These fiery flows move crazy fast and reach insane temperatures, like hotter than your oven on a pizza night. They're like a fireworks show of volcanic eruptions filled with ash, lava, and hot gas, speeding down mountains at 50 miles per hour. Some researchers claim they might even hit speeds of 450 miles per hour, almost as fast as a passenger jet. If you're unlucky enough to be in the path of a flow, you're in big trouble. The heat alone can turn you into a human barbecue, even if you try to hide in a building. The air around the flow can reach temperatures high enough to fry your insides, burn your clothes off, and leave metal melted into your skin, which almost sounds like a Marvel origin story. However, a lot of people have met their end because of these flows. But there's one crazy story about a guy named Luger Silbaris, still sounding like an origin story. So on the 7th of May, 1902, there was a major eruption on the island of Martinique. The night before, Silbaris had gotten into trouble and ended up in jail. Maybe this is a villain origin story. He'd been locked in a sturdy cell facing away from the volcano. The next morning, Mount Pella unexpectedly erupted, destroying St. Pierre within minutes. The flows wiped out around 30,000 people, but Silbaris survived in his cell and became known as the guy who lived through doomsday. The rescue team found him 4 days later. By the way, the cell still stands today. I hope somebody tested him for superpowers. Back on August 21st, 1986, a guy stumbled upon some animals showing no signs of life on his way to Nios village in Cameroon. To his shock, he later found out that everyone in the village had mysteriously passed away. The same thing happened at Lake Manaun in 1984. Turns out, those tragic incidents were caused by something called limnic eruptions, which are pretty rare disasters where carbon dioxide suddenly bursts out of lake waters, creating a hazardous gas cloud. These type of eruptions usually happen in lakes with high levels of CO2, which can be caused by things like volcanic gases and high pressure. Any little change in temperature or pressure can set off an eruption. So, experts have started looking into ways to safely release CO2 from lakes like Manaun and Nios in order to lower the risk of more disasters in the future. In March 2024, a video captured a terrifying moment of a woman disappearing into a sinkhole while browsing through a Chinese department store. Guess she got more than she bargained for. Moving on. The scene unfolded as the floor beneath her gave way, sending her plummeting into the abyss. In the midst of the chaos, another customer frantically ran away before returning to check on the woman who had fallen. Their quick thinking and the swift response of emergency crews and firefighters saved the day, resulting in only minor injuries for both women. I'm glad that lady checked on her because I would be gone. An Anvil cloud is basically a big cloud made of ice particles that forms at the top of really tall thunderstorms, or those huge cumulonimbus clouds. The flat top shape is caused by the air rising in the storm and spreading out when it hits the stratosphere. That's why it's called an anvil. It looks like the tool metal workers use. Duh. The air from the Anvil cloud is cooler than the stratosphere air, which keeps it from going any higher. You can spot Anvil clouds from really far away, sometimes over 100 miles. Often you might see streaks of snow coming from the edge of the cloud known as virga. The snow disappears before hitting the ground because of the dry air. If you notice clouds poking through the flat top or bubbling up, it's an overshooting top, a sign of a super strong storm. Anvils are known for producing dangerous lightning. Normally, lightning comes from the bottom of a storm, but anvil clouds can produce really powerful lightning from the top. This lightning can strike out of nowhere, even from up to 30 miles away. So keep an eye on those anvil clouds if you see one forming nearby. Lahars are no joke. They're basically fast-moving, super dangerous streams of rock, ash, and water that come down the slopes of volcanoes. It's important for everyone to be aware of them. Scientists, policymakers, and even us regular folks. By understanding how lahars work and their potential impact, we can try to stay safe when volcanoes start acting up. Saving lives during natural disasters is the name of the game. There are two main types of lahars: debris lahars and mudflow lahars. Debris lahars are full of solid stuff like rocks and ash, while mudflow lahars are more waterlogged and sludgy. Lahars can be triggered by the rapid melting of snow or ice, heavy rain falling on loose volcanic material, or even a crater-like eruption. The volcano's characteristics and presence of water are key factors in how lahars form and move downhill. When lahars come barreling down mountains at speeds of up to 120 miles per hour, carrying loads of debris, it's a recipe for disaster. Unless you have a surfboard, but I doubt you'll have a surfboard on a volcano. Just saying. Also, it won't work. Going to the beach for a sunny vacation is the best. There's nothing like basking in the sun, feeling sand between your toes, and hearing waves crash against the shore. But even though it's all relaxing and picture perfect, always keep an eye on the water and never turn your back on the ocean. You may know about rip currents and tides, but have you ever heard of square waves? It's a real thing, and it can be pretty scary. Square waves, also known as cross seas, happen when two swells meet, forming a unique square pattern that looks like a checkerboard. They can be found along coastal areas, and while they are rare, they can create waves up to 10 feet high and make it tough for boats and swimmers to maneuver. If you find yourself in the water with square waves, you might feel like you're fighting against two different currents. The best thing to do is to not go too far out to begin with, and get out of the water as soon as the waves become too strong. Square waves are more dangerous for boats and ships, so it's best to stick to the shallow waters and stay safe. Whirlpools and maelstroms are powerful natural forces that have scared sailors for years. They happen when certain weather and current conditions come together just right. Most of them are safe if you stay away, but let's see what they really are and how they form. A whirlpool is basically water that starts spinning when two currents meet, or one current hits something solid like a wall. They can be big or small, depending on the speed of the water and waves. Most aren't dangerous, but there are also maelstroms, which are large, forceful, and violent whirlpools, caused by ocean tides and narrow straits. Tidal currents in places like Norway's Saltstraumen and Moxstraumen can create massive whirlpools. Scotland's Corryvreckan whirlpool is one of the world's largest. Other examples of whirlpools can be found in Japan, Canada, and New Zealand. Are they portals? They're definitely not portals. Researchers have recently looked into ancient underwater volcanic eruptions and how they affected Earth's climate. They studied materials from Bronze Age eruptions to learn more about their scale, dangers, and impact on climate. For example, one eruption about 3,600 years ago in the Aegean Sea caused chaos in Santorini. The study focused on this event to understand its importance. By analyzing volcanic deposits, the researchers gained insights into how future eruptions could affect climate. They discovered that sediment waves from shallow underwater eruptions could lead to tsunamis and impact the ocean floor. These findings help us understand how underwater volcanic eruptions relate to the marine environment, which can help us predict climate changes in the future.
When we look at our planet from space, one color dominates. That's why Earth is called the blue planet. About 3/4 of our world is covered with water. But there's a catch. 96.5% of this water is trapped in the oceans. And if you remember the first time your parents took you to the seaside, drinking that water is a big no-no. So, why is ocean water salty and undrinkable? There are two main reasons. The first is runoff water from the land. Rainwater is slightly acidic. Its pH factor is somewhere between 5 and 5.5. For comparison, pure water has a pH factor of 7. And the acid we find in batteries is a bit more than 0. Such rain erodes rocks when it falls on the ground. This releases ions, such as sodium and chloride. They end up in rivers and streams that eventually empty into the ocean. Living organisms remove some of the good ions, but the rest remains. Over time, this increases their concentration in the water. Oceans have their own salt powerhouse. Vents in the sea floor let out a hydrothermal fluid. Sounds complicated, but it's easy to understand. Water seeps down the gaps on the ocean floor. Then, the magma from the Earth's core heats up the water. There is a chemical reaction that frees seawater from oxygen. It picks up metals, such as iron and zinc. The vents on the sea floor release this metallic water back into the ocean. During an underwater volcanic eruption, the process speeds up. Salt and other minerals are directly released into Earth's oceans. Over time, salt accumulates on the seafloor and forms domes. These deposits occur under dry land as well. Some places on the globe have a large number of salt domes. The Gulf of Mexico is just one example. Beneath the waves, they affect the salinity of water. Other factors that determine how salty a body of water is include evaporation, air temperature, and precipitation. The general rule is that salinity is low near the equator and at the poles. All the oceans and seas in between are likely to have high salinity. Scientists estimate that dissolved salts make up 3.5% of the weight of the world's seawater. The waters that empty into the ocean, such as lakes and rivers, are fresh water. So, why is the seawater salty? To answer this question, we must travel into our planet's past. Researchers believe that primeval seas weren't as salty as they are today. But over time, rainfall washed away the rocks on land, transporting vast amounts of salt into the oceans. The process has been going on for more than 3.8 billion years. Today, some 4 billion tons of dissolved salts end up in Earth's oceans every year. The input and output of salt are fairly balanced. This means that seawater's salinity is stable. So, why can't we drink seawater? We already take salt into our bodies with food and drinks. It is called dietary salt. The World Health Organization recommends that humans consume no more than a teaspoon per person, per day. You shouldn't go over that amount if you want to keep your heart healthy. Centuries ago, salted beef and pork were the standard diet of seafarers. Meat was preserved using salt. At sea, fresh fruit and vegetables would go bad after just a couple of weeks. Before refrigeration, this was the only way to keep food fresh. Pickling was another option for storing food. The reason why we can't drink seawater is the salt content. The percentage of this mineral in our blood is nearly 4 times lower than the percentage of salt in seawater. Our body simply cannot process such a high amount of the substance. When we intake salt as part of our diet, we also drink liquids. When you serve pretzels, you probably have a glass of water or juice nearby. It helps quench the thirst and keep the salt levels in check. If we drink water straight from the ocean, the exact opposite happens. We just become thirstier. Our body absorbs both water and salt. They end up in our bloodstream. The organs responsible for getting all this salt out of our blood are the kidneys. But they need water to perform their duty. The higher the salt content, the more water they need to wash it away. When the process repeats itself several times over, you become dehydrated. This is the process of losing water from the body. And there's another catch. You start releasing more water than you take in when you drink seawater. The difference leaves you thirstier than you were when you started drinking seawater. Not a good idea to begin with. But some marine mammals, such as whales, seals, and even seagulls, can drink water from the sea, just like we drink tap water. The kidneys of these mammals are super efficient. Birds have special glands in their beaks that prevent salt from getting inside their bloodstream. Scientists found that the only land animal that can drink seawater is the camel. And if you ever wondered if fish drank seawater, they do. The gills and kidneys help them pump out the excess salt. For humans to drink ocean water, it first needs to go through desalinization. This is the process of removing salt from seawater, and there's a lot of it to take away. Estimates show that if we laid out all the sea salt across Earth's landmass, it would be higher than the Statue of Liberty. That's why desalinization on a global scale isn't realistic. Right now, less than 0.5% of the drinking water we produce comes from seawater. And the demand for potable water is only going to increase. The current rate of consumption means that the demand for fresh water doubles every 20 years. The biggest issue with desalinization is the energy cost. It takes 10 times more energy than other water production methods, and the carbon footprint is huge. Large desalinization plants often need to have their own power stations. This is all because of the technology behind the process. Salt dissolves easily in water. It creates a strong chemical bond with water that is hard to break. Desalinization facilities mostly use reverse osmosis to achieve this. Large pumps exert pressure on seawater to push it through a filter. Its membrane is so fine that each pore is a fraction of the size of a human hair. The filter allows for water molecules to pass. Larger salt molecules remain trapped in the membrane. For every quarter of a gallon of fresh water the plant generates through desalinization, there is the same amount of water that is now twice as salty. Hardly the ideal method of water purification. The idea that humans could drink seawater isn't new. In the mid-4th century BCE, the famous Greek philosopher Aristotle considered using a series of filters to remove salt from water. Ships in the 16th century had small, portable distilleries that could boil seawater. This was merely patchwork, since exposing seawater to high temperatures doesn't make it drinkable. Such thermal processing only sterilizes the water. You would need to catch the steam that evaporates and wait for it to cool down before it's safe to drink. This is a complex and time-consuming method that is probably not worth the effort. Let us imagine for a second that we got rid of all the salt from the Earth's oceans. We would get an endless supply of drinking water, but at what cost? There are millions of animal and plant species that are adapted to salt water. These include plankton, the basis of all marine life. They wouldn't have enough time to adapt to the new conditions. Not all fish are like the salmon, which thrives both in fresh and salt water. The sudden switch would also have a profound effect on our planet. Since freshwater is less dense, it would immediately cause the ice cap in the Arctic to sink by 4 inches. This would trigger the largest tidal wave the planet has ever seen. Although the idea of desalinization on a global scale sounds good on paper, we should take it with a grain of salt.
This planet looks lifeless. Lifeless, brick red, and very, very dry, like a desert. But only until you reach one of the poles of the red planet. That's where you come across a seemingly endless ice cap. So, if you've been imagining Mars as an extremely dry place, you might need to change your opinion. Scientists think there could have been a lot of water on Mars in the past. What makes them think so? They've found loads of ancient river valley networks and lake beds on the surface of the red planet. Plus, on Mars, there are minerals and rocks that could have only formed in liquid water. Mars might even have experienced terrible floods 3.5 billion years ago. These days, there's still some water on the red planet. It's true that Mars's atmosphere is too thin for this water to stay in its liquid form on the surface of the planet. But under the surface, it's a different matter. You can find water under the surface of the planet in its polar regions. The only place where this water is visible is at the North Polar ice cap. Also, sometimes, salty water flows down crater walls and hillsides, and there are tiny quantities of water in the planet's atmosphere, but it only exists as vapor. Anyway, now that we know for sure there is liquid water on Mars, could we probably use this water during a human-operated mission to the Red Planet? This way, the spaceship coming from Earth wouldn't have to bring its own water. It would make its cargo way lighter, which in turn would decrease the cost of the mission. The spaceship would just need to take enough water to get to the Red Planet and bring along the equipment astronauts will need to filter Martian water to make it drinkable. But it's not all sunshine and rainbows. The main problem is that the water found on Mars is salty. It might even be as salty as the oceans on our own planet. But these salts aren't what you can find on Earth. If a person consumed a certain amount of them, they would be highly toxic to the human body. On our planet, these salts are formed as byproducts of rocket fuel, as well as in road flares and fireworks. Naturally, they only occur in very dry areas. If there are no particular bacteria to break them down, these substances accumulate year after year, and their concentration in water is constantly increasing. But in theory, it's possible to purify even such water. The process of filtration could help the astronauts get rid of 90% of harmful substances. Then, they could use a UV disinfection unit. This would also help to get rid of any foreign microbes, if there are any, that might be hiding in the water. This stage would not only protect the astronauts, but also prevent them from bringing any dormant Martian microbes back to Earth. In other words, future travelers to Mars shouldn't have too many problems with drinking water on the Red Planet, but only if they bring the right purification equipment that can deal with any water quality. Because however bad running out of water in the middle of a desert is, experiencing it on another planet sounds much more terrifying. Now, I've got another question. If there is water on Mars, might there be other worlds in our solar system where we can find water? Sure, let's visit some of them. We'll start with Europa, one of the largest moons of Jupiter. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. There's also some evidence that the ocean might have warm water radiating from the moon's equator, which also means there could be not just life, but complex life on Europa. Well, I guess we'll find all about it in 2030 when NASA's Europa Clipper will reach the satellite and conduct its own investigation. And we're moving on to Enceladus, Saturn's moon. People have known about this tiny sleepy world since 1789. The diameter of the moon is a mere 310 miles, but despite its small size, it's one of the most intriguing places in our solar system because it too is likely to host a warm and salty liquid ocean. Watery eruptions happen on Enceladus rather regularly. The moon spews from its ice geysers more than 1,000 tons of water every hour. This water is mixed with organic molecules, salt, and other substances. Astronomers think that the ocean might be warm thanks to the tidal influence of Saturn. The planet's tug may cause hydrothermal activity, warming the oceans. There are also places in the solar system that might have water on their surface, but its presence hasn't been confirmed yet. For example, Ganymede, another moon of Jupiter. It's the largest moon in the solar system. It's even bigger than Mercury. Astronomers have long believed there is an ocean beneath the 100-mile thick ice crust covering the moon. And in 2015, Ganymede's auroral activity also hinted that this ocean could be warm and salty. Unlike on Europa, ice geyser activity on Ganymede hasn't been spotted yet. The reason might be a much greater distance between Jupiter and Ganymede than that between the gas giant and Europa. Also, there are the maybes. Those are worlds where there seems to be water, but we don't know to what extent it is liquid. One of such places is Callisto, which, have you guessed it, is another of Jupiter's moons. It's pretty far from its parent planet and also doesn't get as much radiation as other moons. Plus, it has a magnetic field, which definitely adds some protection. Astronomers claim there is water in this faraway world, but the moon's lack of geological activity might mean that it can't have an ocean without some kind of space antifreeze. In other words, all that water on Jupiter's satellite can be a huge, and I mean huge, chunk of ice. Now, let's visit another space body, but this time, it's not a moon, but a dwarf planet. Look, this is Ceres. Even though people have known about it since 1801, its small size made it difficult to study. Until not so long ago, this space body was considered to be a rocky world. But after the Dawn spacecraft arrived at Ceres in 2015 and examined the dwarf planet, a new theory appeared. Ceres might be less of a rocky ball and more of a watery planet covered with an icy mantle and a slushy ocean moving beneath. If it's true, Ceres could become the nearest to Earth world with an ocean. Titan is Saturn's largest moon. It has some of the most abundant pools of liquid in the solar system. Its surface is a slurry of water ice and ice made of lots of different compounds, for example, hydrocarbons. The satellite also has dense clouds that regularly burst with rain. And if you visited this place, you'd see rivers, lakes, and an ocean made up of methane and ethane hiding under the icy crust. Now let's talk about poor Pluto, which has changed its status a couple of times. When NASA's New Horizons flew by the dwarf planet in 2015, it discovered a hint of something totally unexpected: an ocean. Pluto is an icy world. But there are two things that make scientists think that Pluto might have once hosted an ocean. First, a theory that Pluto and its 5 moons could have been formed out of the same materials after a powerful collision. And second, the tidal forces between Pluto and its largest moon, Charon. Even better, this leaves open the possibility that the ocean is still around. We just need more time to examine the dwarf planet. It's so close to us, at least in terms of space, but there's still so much we don't know about the moon yet. For example, Chinese researchers have collected soil samples from the moon and found out there might be billions of tiny glass spheres on the lunar surface. What's really cool is that they might hold enormous amounts of water. These tiny spheres form when meteorites hit the moon at crazy speeds, sometimes at hundreds of thousands of miles per hour. When that happens, a strong explosion sends bits of the moon's crust flying into the air like popcorn. As these chunks of crust cool down, they create little glass beads that look like tiny glittering spheres. These beads are so small that they're like crumbs sprinkled over the moon's surface. Scientists call them impact glass. And it turns out the soil on the moon is holding a secret ingredient that can make water: oxygen. So, these tiny glass balls are like little capsules with oxygen inside. There's a special type of wind called solar wind, and it's made of protons and electrons. When protons hit the capsules, they mix with the oxygen inside and finally make water. But the most amazing part is that some of these glass balls with water inside get hidden under a layer of the moon's dust called regolith. So if we go on a mission to the moon, we'll have hidden reservoirs of water underground. It's as if someone has prepared some canned food for us to survive. Because you can't drink that water directly from these glass beads, you're supposed to collect them and then boil them in an oven to extract the water. When they cool, they release vapor, so you'll have regular liquid water in a bottle. That way, astronauts on their missions will be able to stay longer up there, considering these secret stashes. And the coolest thing is that these glass beads are very common on the moon. They're spread from the poles to the equator, which means there might be enough water even for generations that might come to live there one day. There are other spots where we can find water in space too. For example, scientists found an extremely big cloud of water vapor that's 12 billion light years away from us. Not within reach, of course, but it's still good to know. And we're talking about something bigger than we can imagine. It's thought the cloud contains at least 140 trillion times the amount of water in all the oceans and seas on our home planet. Imagine swimming or scuba diving there. It's like taking a dip in a giant water balloon that's traveling through space. I mean, you wouldn't have a way out considering the amount of water in there, but hey, at least the view would be magnificent. Water is actually everywhere across our solar system. It's mostly in the shape of atmospheric gas or ice, and sometimes even in its liquid form. And there are probably many water worlds in our galaxy too. Scientists from the University of Copenhagen have discovered exciting new evidence about how planets form in our solar system and beyond. Their computer models have confirmed the interesting theory of pebble accretion, which means that planets form from tiny pieces of ice and dust. This theory is based on the observation of disks around young stars that are made up of pebbles that come in several hundred Earth masses. As these pebbles collide and clump together, they form protoplanets and eventually planets. What's even more exciting is water could be an important ingredient in this planet's making. It also means that the water may not have come to Earth by chance, for instance, via icy comets hitting our home planet. Instead, maybe it was there from the very beginning. Perhaps planets in our neighborhood, like Mars and Venus, formed with water as well. Scientists also say we shouldn't assume we're a special case just because we have water. There could be many planets all over our Milky Way galaxy as big as Earth that have water too. That means there could be many worlds in our galaxy with continents and oceans, which could also mean there is a great deal of life out there waiting to be discovered. But just because there's water somewhere, it doesn't mean that place would be a good spot for an interstellar summer vacation for future generations. Water on many planets is probably embedded in rock or fills underground oceans. Researchers have checked more than 40 exoplanets we know about. They're all smaller than Neptune and located around something we call red dwarf stars. These make up 80% of all stars we're familiar with in our galaxy. They're cooler than our Sun and also the smallest type of hydrogen-burning stars. And there could be more planets with enormous amounts of water than we thought. Plus, this water can take up to half of the total mass of these planets. Scientists know this because they've been studying the density of these exoplanets. They have realized they're too light to be made entirely out of rock. I've mentioned Venus before. Today, it's a hot, rocky planet a bit smaller than Earth, with a dry atmosphere and only some traces of water vapor. It's also very poor in oxygen. But in its early stages, the planet may have been a completely different world with liquid water and even clouds, which means it's possible there used to be life. What if Venus used to be similar to Earth, with oceans and moderate temperatures? It would be great if it stayed that way, because these seem like good conditions to develop life, so we'd probably be writing letters to some of our space friends from there, or visiting them already. But the scenario went in a different direction for Venus about 700 million years ago or so. The planet got so hot it lost all of its oxygen. That's why it wasn't able to form liquid water on its surface. Instead, it developed a thick atmosphere made up of carbon dioxide, which made this world even hotter than Mercury, even though it's twice as far from the Sun. Even icy comets pelting it couldn't bring water back to its surface. We can't do it either in some artificial way. It would be like trying to grow a delicate flower in a desert. No matter how much you water it, if the conditions are too dry and harsh, the flower won't survive. But some people thought the water in the atmosphere of our close neighbor could be enough for developing life. Plus, scientists have discovered there is a compound called phosphine that's often associated with living organisms on Earth. Maybe in the past this was enough, Today, the amount of water on Venus is so small, even our toughest microbes that are extremely tolerant to droughts wouldn't be able to stay alive there. Phosphine is still a cool discovery worth investigating, but not something that tells us there could be life on Venus. Jupiter might be a more likely option for that. The Galileo probe flew through the atmosphere of this magnificent gas giant to measure the temperature and water activity. It found out there was enough water for life to exist in the planet's clouds, but sadly, there are not enough nutrients there. Plus, there's too much ultraviolet radiation, so most organisms wouldn't actually be able to survive there. And everyone knows Europa, one of Jupiter's moons. It's that very place in our solar system that has the biggest chances to support life. Its icy crust probably hides an ocean underneath. And because of Jupiter's gravity that affects Europa, the ocean is not frozen, but remains liquid. The ocean might be warm under that icy crust, probably thanks to hydrothermal vents. Enceladus, one of Saturn's moons, probably has even higher chances to host life than Europa. And it's one of the best candidates to have a beautiful, warm, and salty ocean beneath the surface. It has the coolest ice geysers that catapult into space about 1,000 tons of water every hour, together with salt, organic molecules, and some other materials. Imagine a world where the red, barren landscape of Mars is transformed into a lush and verdant garden. A world where water flows freely, carving canyons and creating lakes and oceans. Can we achieve such a world by pouring the Earth's water onto the surface of Mars? And don't rush to say no. Let's explore this possibility. Alright, let's say we could magically transport all of the water on Earth to Mars. This supersized game of water pong would be crazy in both engineering and logistics. So how do we even do that? First of all, we're talking about millions and millions of gallons of water, which is no small feat. We would need some really big tanks to get all this water off the Earth. We would also have to figure out how to launch it all into space. This would require some serious rocket technology, as well as a lot of fuel. We could probably create an entire fleet of spacecraft specifically designed for the task. Just imagine that, a fleet of giant water tankers packed with tons of carefully harvested water, blasting off from Earth's surface and hurtling through space at unimaginable speeds. Wouldn't that be a cool sight? Now, another way. Probably a better one would be to launch a large number of smaller missions over time, each carrying a smaller amount of water until enough of it has been transported to Mars. So, let's say we manage to do all that. What happens next? After we get to Mars, we'd need to distribute this water all across the planet. We could use a network of underground pipes or some special drones to transport the water to different locations. This is just some basic things, and as you can see, we already need a lot of planning and resources. Moreover, a crazy operation like this would require a massive coordinated effort from scientists, engineers, and space agencies all over the world. And let's not forget about the costs. No wonder that scientists don't really consider it a viable plan. But the scale of this operation isn't the only problem. Hypothetically, let's say that we figured all that out and poured the Earth's water on Mars. Now what? Well, believe it or not, it would be almost completely useless. Our main challenge will be the atmosphere and current climate of Mars. Mars is a dry desert with an atmosphere that's only about 1% as thick as Earth's. This means that any water poured onto the surface would quickly evaporate. It would be pretty hard to create a stable environment when the entire lake can go poosh in a matter of seconds. And if the water doesn't evaporate, then, on the contrary, it will turn into ice. Mars' surface temperature is well below freezing. Thin atmosphere only makes things worse. Another challenge is that Mars has a very weak magnetic field, which means it has little protection from the solar wind. Solar wind is a stream of charged particles that are constantly flowing out from the sun. These winds are pretty dangerous. They can strip away any water that's put on the Mars surface. Also, the solar radiation on Mars is much stronger than on Earth. This would make it even more difficult to maintain any liquid water there. And finally, don't forget that we also need to purify this water to remove all the bacteria before drinking it. But let's not give up. If we stay super optimistic, we can still try to solve these problems. Basically, we need to find a way to maintain liquid water in one place for a long time and make sure that it doesn't freeze or evaporate. So how do we do it? There are a few ways we can go about it. Number 1, insulation. We could wrap all the water containers in insulation materials, like foam for example, or some reflective materials that can help to keep the water from freezing. Number 2, heating. We could use various heaters and devices to keep the temperatures above freezing, even thermal blankets. Although this would require a lot of energy and would be a difficult task. Number 3, underground reservoirs. We could dig a large hole and cover it with a transparent material to allow sunlight to pass through. This would help keep the water warm and insulated. Number 4, salinity. Adding a small amount of salt or other dissolved minerals to water can lower its freezing point. Although we'll need much more salt for things like lakes, and this method isn't the most efficient. And finally, number 5, building a greenhouse. We could build a greenhouse or some other structure that can trap heat and create a more Earth-like environment. This option is probably the best one. After all, a greenhouse would also help us to grow various plants or other organisms. Yay, life! Alright, great. Let's say we've discovered some way to store water on Mars and keep it there in a liquid, lukewarm state. What now? What impact would this have on Mars? Actually, this would be great. If we were to pour all this water on Mars, it could have drastically changed the climate of this cold, red desert. First of all, we could create a so-called greenhouse effect. It's when gases in a planet's atmosphere trap heat, causing the planet's temperature to rise. And yeah, this is pretty bad for Earth, but for Mars, whose temperatures jump between 70 and negative 200 degrees Fahrenheit, it would be awesome. This could cause the atmosphere to thicken and lead to the melting of the polar ice caps. Wouldn't that be awesome? Mars would begin to gradually turn from a lonely desert into Earth 2.0. It also means that the planet's atmosphere will change. For example, the weather patterns. Clouds could form on Mars, rains would begin to fall. And rains, as we know, transfer water from one region to another, which would mean they could water plants if they appeared on Mars. But all of this is pure speculation. We can't be completely sure what kind of impact pouring water on the Martian surface would have on the planet's climate. Perhaps, to create this greenhouse effect, we would need much more water than what we can transport. But if despite all these challenges, we had succeeded with our mission and made Mars much warmer and moist, could life have been finally born there? Unfortunately, that would still be pretty unlikely. Yes, water is very important for creating life, but that's not all we need. The composition of the Martian soil isn't very conducive to supporting life. The soil is mostly made of minerals called regolith, which are composed mainly of dust, sand, and other materials that aren't very good for plants. Theoretically, we could terraform Mars. Terraforming is a gradual, slow change of the planet so that it becomes suitable for our life, but this would be a very complex, long, and costly process. Oh, and by the way, what would happen to our Earth after all that? We took quite a lot of water, didn't we? From Earth's perspective, transporting water to Mars would require an enormous amount of resources, including energy and different materials. And the amount of water we'd have to spend would be staggering. The loss of such a large amount of water from Earth's own reserves could have a significant impact on our planet, especially in areas where water is already scarce. So basically, this is a really bad idea, no matter how you look at it. Yeah, it may sound interesting, but it's not a viable plan at all. It would require too many resources, too much money, and it wouldn't even be worth it. That's why scientists and space agencies don't consider this idea seriously. Besides, there are many other more realistic and achievable goals in the field of Mars exploration. For example, we can keep studying the planet's geology, atmosphere, and potential for past or present life. These studies would help us to find some resources that could support future human exploration. Overall, we need to answer many more questions about Mars before we even begin to consider colonizing it. So let's keep an eye on scientific news and updates. Ever wondered what Earth would look like if it was split evenly between land and water? I mean, like 50% land and 50% ocean. Like a cosmic pizza with just 2 toppings split equally. First things first, we all know that water is essential for life. That's why scientists search for water on other planets to find potential life. On our own planet, water covers about 71% of its surface, with most of it found in the oceans. What if we took away almost a quarter of that water and replaced it with land? If we did balance out the land-to-water ratio, we would see some pretty drastic changes. Due to the sea level drop, regions around the North and South Poles would dry up completely. Meanwhile, every continent on the planet would expand to reveal an enormous amount of new territory. This would be equivalent to the current surface areas of Asia, Europe, Africa, and North America combined. Imagine all those new vacation spots you could explore with all that land. This shift in the ratio of land and water wouldn't be all sunshine and rainbows, though. With much less water covering the surface, our ocean currents would get messed up, leading to a destabilized climate. This would mean colder temperatures around the poles and even hotter temperatures in the already scorching equatorial regions. Rain levels would drop, creating dangerous droughts and new deserts in many inland areas. Let's not forget about the creatures living on Earth. Plants, animals, and humans would all need to adapt to being less dependent on water. Some animals may even evolve to be smaller or switch to a strictly carnivorous diet due to water scarcity. And sadly, lots of life forms in our current oceans would struggle to survive, which would be a huge bummer for all the fish lovers out there. Let's try to imagine a totally different scenario for our planet next. Back in 1884, the press reported on an astronomer who claimed to have discovered a cubic planet beyond Neptune. We've sure come a long way since then. We've come to know that in our universe, there's no possibility of planets being square, at least based on the information we have today. Let's travel back in time to 4.5 billion years ago when our own planet was just a hot mess of gas and dust. As this chaotic cloud collapsed, a hot star formed and began to attract all nearby matter with its gravitational pull. Eventually, a rotating disk formed around the star, and collisions between particles led to the formation of massive bodies, planets. And because gravity pulls equally from all sides towards the center, planets naturally take a spherical shape. But what if we spice things up and skew the distribution of gravity? Well, if you're feeling adventurous and want to live life on the edge, then welcome to the cube Earth. Yay! We'd have 6 sides now, but don't get too excited. None of them would be any fun. You'd constantly feel like you're climbing up a steep hill, no matter where you go. That's because gravity is strongest at the center of each face. So the further away you were from the center, the stronger pull you'd feel. Say goodbye to taking standing tall for granted. If you found yourself on the edges of the cube Earth, you'd find no lush and vibrant landscapes. All the water would pool at the center of each face, leaving the edges rocky and barren. And forget about breathing easily. The atmosphere along the edges and corners would be too thin or non-existent to support life. But we'll come back to that later. The climate on the cube Earth would depend on how it would rotate. If it's spun on an axis through 2 faces, then the climate would be similar to what we have on Earth now, but more extreme. The top and bottom faces would be polar, while the other 4 would enjoy an equatorial climate. However, if the cube Earth rotated through its corners, each side would have a climate with more moderate temperatures and precipitation. Say goodbye to extreme weather, but also wave goodbye to your equatorial paradise. On the bright side, you would probably be able to walk into outer space. Since the atmosphere is held down by gravity, and gravity would now be pulling towards the center of each face, the atmosphere would be thicker there and thinner towards the edges. If the cubic Earth had the same volume as our round world today, its sharp corners would poke out beyond our atmosphere, creating unprotected and uninhabitable areas. But who says you wouldn't be able to rent a spacesuit and stand on top of the world and outside of it at the same time? Talk about taking your vacation to new heights. How about if our planet was completely covered with water? Well, it turns out that ancient Earth might have been just that, a water world. According to some researchers, our planet was mostly covered with oceans about 3 billion years ago, with only a few scattered islands popping up here and there. The scientists who made this discovery have been studying rock samples found in Western Australia. By analyzing these rocks, they were able to determine that they formed in a hydrothermal vent system on the seafloor over 3 billion years ago. This information could have some major implications for how we understand the origin and evolution of life. See, scientists still have a lot of questions about where Earth's water came from and when it appeared. But by studying these ancient rocks, they're hoping to get some answers. One way they're doing this is by looking at the oxygen found in the rocks. You see, water with different values of oxygen can tell us a lot about the environment in which it formed. And the researchers found that the rocks from 3 billion years ago had heavier oxygen content than we see in our modern oceans. This suggests that at that time, dry land hadn't emerged yet, which means that Earth was mostly covered in water. Now, this might not seem like a big deal, but it could actually help us understand how life first formed on Earth. If our planet was completely covered with water when the first single-celled organism emerged, then they probably didn't form on land. And if that's the case, it could mean that other water-covered planets might be ideal places to search for life. Our planet may never be fully covered in water ever again, but we might end up losing some, if not all, of our planet's hydration. Here's the deal. The sun is going to get hotter over the next few 100 million years. This isn't anything to do with humans and our shenanigans. It's just a natural thing that happens with all stars. The bad news is that the sun gets hotter, our planet is going to heat up too. And if things get really toasty, we're going to start losing our oceans to evaporation. Sure, we've got plenty of time to hit the beach before that happens. Experts have been working hard on a super fancy computer model to predict exactly when all this is gonna go down. And according to them, we've got around 1 billion years until things get seriously steamy. You might be wondering how they came up with that number. It turns out that when the sun gets hotter, it makes the atmosphere warmer too. And as the atmosphere warms up, more and more water evaporates from the oceans. There's a catch though. Water vapor is actually a greenhouse gas, which means it traps heat and makes things even hotter down there on the surface. As we lose more and more water, we're going to end up in a loop where the planet just keeps getting hotter and hotter until there's no water left at all. But hey, it's not all about us. This research could actually help us find other planets with liquid water. By figuring out what kinds of conditions are needed to keep water on a planet, we might be able to identify some other hospitable worlds out there. And who knows, maybe in 1 billion years, we'll have colonized one of those planets.
Here on our good old planet Earth, water is literally everywhere. Not only in the oceans and seas, but also in the atmosphere, in the ground, and even in our cells. It covers as much as 71% of the surface of our planet. Looks like our planet should have been called water and not Earth. But what would happen if water and land were distributed equally? What if half of the planet became land and the other half was water? Well, let's find out. First of all, let's discuss what we mean by equally. Despite all the things mentioned earlier, there's actually not so much water on our planet. Yeah, if you collected it all in one giant drop, it'd be slightly larger than the United States in size. And all this amount of water would only be 0.02% of the total mass of Earth. So, it turns out that all these horrifying unexplored ocean depths are basically nothing. And now, just imagine if we changed the composition of our planet by leveling the volume of water and land. What would happen then? Then, we'd get a very creepy ocean planet. The planet would look like one boundless ocean. It'd be very unlikely that you'd find even a couple of small islands on it. And if you did find them, they'd probably be the tops of huge underwater mountains. This world would be practically uninhabitable. If you were on its surface, you wouldn't be able to see the sun or anything else in the sky. You wouldn't know what time of day it is or where exactly you are, all because of the incredibly thick fog and clouds. This kind of weather would be permanent on such a planet. Moreover, you wouldn't even understand where the fog ends and the water begins, all because the humidity would be that high. But could there still be life? Well, maybe inside the ocean itself? Unfortunately, this is also quite unlikely. You see, to get to the bottom of this ocean, you'd have to swim vertically down, not for several hours, but for several days. And even after such a journey, you wouldn't see the bottom yet. The ocean wouldn't be bottomless, of course, but the seabed would consist mainly of very hard, impenetrable ice. But not the kind of ice we're used to. This ice would be exotic. There are different types of it, called Ice 5, Ice 6, and so on. Usually, these types of ice aren't as cold as regular ice and may not melt even at high temperatures. And there would be almost no algae or anything like that. So fish would simply have nothing to eat. That's why, if life appeared on such a planet, it would be a miracle. This life would have to withstand a pressure of more than 20,000 Earth atmospheres. Even the most horrifying monsters from the Mariana Trench would be nothing in comparison to the creatures you'd find on this ocean planet. But could we, humans, live there? Well, theoretically, yes, but it would be extremely hard. We could create something like giant underwater stations, but we would still have thousands of problems. Where to get food and other resources, how to repair stuff, and so on. So it would be far from the best option. Okay, now we know that an ocean planet doesn't sound too endearing. What about another option? What would happen if the surface of the Earth was 50% water and 50% land? For this to happen, we'd need to reduce the current amount of water from 71 to 50%. In this case, the sea level would drop by about 2 miles, and a quarter of our planet would become dry land. Although it doesn't sound like much, the consequences would be disastrous. Right now, there are 5 interconnected oceans on Earth: Atlantic, Indian, Pacific, Southern, and Arctic. But if we lowered the sea level, all these oceans would simply disappear. They'd turn into separate closed reservoirs and seas. On the contrary, all the continents would merge into one giant landmass, almost as if we swapped the land and water. At first, it would seem pretty cool. Now, you could literally walk around the world. However, the amount of land you'd have to travel would also increase. Every continent on the planet would grow in size. All this new territory would be approximately equal to the current area of Asia, Europe, Africa, and North America combined. Well, that would be a huge mass of unused space. But what would we find on these new territories? Most of them would be pretty flat. But in places where there used to be deep oceans, you would see vast corridors and steep crevices. Now, here's another cool thing. Most of the sunken cities would return to the surface. And no, unfortunately, we wouldn't find Atlantis among them. But there would still be a lot of other cool places. For example, the ancient Roman city of Baia, which, according to legends, was basically a paradise on Earth with all its luxurious villas and gardens. Or Heraklion, the city that went under the sea thousands of years ago and was considered a myth for a long time. So yeah, we could organize tours to these ancient places. But of course, not everything would be fun and games in such a world. Due to a severe loss of water, ocean currents would be disrupted, and this would lead to very serious climate problems. The ocean absorbs the heat radiated by the sun. Thanks to the currents, this heat is distributed all over Earth, which creates a stable and pleasant climate. But if these currents were disrupted, then the temperatures on Earth would become more extreme. It would get much hotter near the equator and even colder around the North and South poles. So yeah, unfortunately, the Antarctic ice wouldn't save us. It would be quite the opposite. The regions around the North and South poles would completely dry out, basically turning into dry, cold deserts. In addition to heat, water also absorbs carbon dioxide from the air, and since the oceans wouldn't be able to absorb it, this gas would begin to accumulate in the atmosphere. This poisonous excess would cover the entire planet. The average temperatures would increase, and the whole planet would start to dry out slowly. Massive forest fires would break out, and so on. Sound familiar? Now, to make matters worse, there would be nothing to extinguish these fires, because, rains can't form from nothing. So yeah, the precipitation levels would fall, and this would lead to dangerous droughts. We'd get a bunch of new deserts on all the continents. Despite getting all those new territories, it's unlikely that we could somehow build new cities and towns there. Many of these territories would be uninhabitable, not only because many forests and plants would disappear, but also because most animals would migrate to more pleasant places. As a result, we would have great difficulty finding any food at all. So, all life on our planet, plants, animals, and people, would have to adapt to new living conditions. They would have to evolve quickly and get used to the constant shortage of water. Animals, for example, could shrink in size because of this. Many of them, due to the lack of grass and moisture, would switch to a strictly carnivorous diet. And of course, we would have to say goodbye to the huge abundance of marine life. Many fish would disappear forever. Humans, most likely, would make a big evolutionary step backward. Not only because we would lose a large number of resources and move to new territories, but also because we would also lose access to one of the most important sources of energy in the world, hydroelectric power. Without electricity, many factories would stop working. To say that this would cause a large-scale crisis for us all is sadly obvious. So, our current ratio of water and land is the best possible option. If there was too little or too much water, the consequences would be awful. That's why we need to protect the current conditions with all of our might.
Is it possible to put out the sun? For example, what would happen if we poured all of the Earth's oceans on it? Or even more water? Well, let's find out. The universe is a place full of mysteries. Since ancient times, scientists have been arguing about how space works. But none of us has ever doubted the existence of one thing: the sun. The center of our solar system. It's big, bright, and immortal? Nah, not really. Actually, the sun is just an ordinary star. It consists of 75% hydrogen, a little helium, and a pinch of other heavy elements. Gravity holds it all together. But in around 5 billion years, the life cycle of the sun will come to an end. The hydrogen inside it will run out. Our star will begin to grow gradually, and you can't even imagine just how big it will become. And then it will start eating all the nearby planets. That's when we'll regret being so close to it. After eating us all, the star will remain a red giant for another billion years or so. And then, sooner or later, it will begin to shrink and fade, turning into a white dwarf. In the end, nothing will remain of it but a bright and colorful planetary nebula. But don't get scared. Right now, the sun is in the middle of its life cycle. It was born about 4.5 billion years ago, and about the same amount of time remains. Fortunately, we were born during the star's best and most stable period. In other words, there's no reason to worry. So let's find one. How about speeding up the sun's life cycle with the help of water? We'll try to collect all the water on Earth and pour it onto the sun. First, we'll need a bucket. No, not this one. We'll need a really, really big bucket. The one that can contain around 326 million cubic miles of water. It will be equal in size to the distance from Washington to Chicago. Or if we can only find ordinary buckets, there should be around 70 quintillion of them. This is a number with 18 zeros. Okay, imagine that we magically got that many buckets. It's time to put out the sun. We splash the star with all this water and nothing? Seriously? Oh, just look at this. The sun has probably felt sorry for us and produced one little solar flare. It turns out that all water on Earth is actually just a pathetic drop for the sun. People often underestimate how much bigger the sun really is than our planet. In reality, it can fit more than 1,003,000 Earths. So yes, the sun won't go out or even get colder. It won't even notice that we've done something. But let's not give up. We really want the sun to go out for some reason. What happens if we pour just enough water on it? And how much is this enough? Remember our quintillions of buckets? Well, we actually need about 370 octillions of them. This number has 27 zeros. It's hard to even imagine, so let's just say that it's a lot of water. Now, let's splash it all over the sun again. Wow, just look at the steam! But the sun hasn't gone out again. On the contrary, it said thank you and suddenly became much bigger and brighter. What's happening? You see, the sun isn't actually a campfire. Inside bonfires, candle flames, there's a chemical combustion. When we pour water on the fire, the water absorbs the heat of the flame and cools it to such an extent that it can no longer maintain the burning reaction. It also blocks the fire's access to oxygen. Water basically stops the chemical process. But the burning of the sun isn't the same reaction. Even though we say it burns, it's not entirely true. What happens there is called nuclear fusion. It's one of the most violent and craziest reactions in the universe. There are many layers of hydrogen going deep into the sun. If you take 4 hydrogen atoms and ram them together, you're left with an atom of helium. When we talk about the sun, the process is a little more complicated. When the star tries to carry out that fusion, positive protons repel each other. It takes a lot of force and energy to somehow squeeze them together. Fortunately, there's a magical force in space. It's gravity. The sun takes up 99.8% of all the mass of the solar system. Pretty heavy, right? And all this mass is what holds the sun together with the help of an incredible gravitational force. So, gravity takes quadrillions of these little hydrogen atoms and pushes them together every second of every day. And when they collide, they release some energy. So, unlike fire, the sun doesn't need oxygen to live. It needs hydrogen. And we all know that water is H2O. It consists of hydrogen and oxygen. So this is literally fuel for the sun. It's like trying to put out a fire with gasoline. More importantly, the extra mass added by water will make the sun heavier. Now, gravity says, thank you for your help. And then it starts to collide protons with each other even faster. And thanks to this, the synthesis speeds up. Great, we've made the sun incredibly strong, and now it has eaten us, along with other nearby planets. And if we keep adding water, the sun will sooner or later collapse in on itself. It will blow off its outer layers and become a black hole. Awesome! Now it will pull inside absolutely everything around. Good job, guys. Let's press rewind because clearly our water experiment was a mistake. One small solar flare sounds much better. Alright, we're back to our usual calm sun. But it seems like there's something that we've forgotten. Well, apparently, water was critically important for life on Earth. Who would have thought? Now there's a huge amount of unmoving fish and other marine creatures lying around where the oceans used to be. Poor things. As for deep sea creatures, they simply didn't withstand such a sharp change in pressure. Algae and corals have also dried up. Wait a minute, weren't they responsible for producing 50 to 80% of the world's oxygen? Oops, it's time to put on some oxygen masks. And how are things on dry land? I mean, now everything is just land. But you get the point. Wow, this whole place is lit, and I mean it literally. If there are no oceans, then there are no clouds or rain. Now there are forest fires everywhere. Poor animals have to escape and leave their homes. Oh my. And it's not like they'll be able to find a new home, because all plants, of course, will dry up quickly. There will be literally no place for living left on the planet. So now Earth looks like a giant desert. Great! But people have been living in deserts for thousands of years, right? Maybe they'll know what to do. They won't. After all, people in the desert also need to drink. So now there's total chaos everywhere, and survivors fight for the last drops of water. If there are any survivors at all. In fact, no matter how much they fight for resources, their fate is sealed. The ocean absorbs a huge amount of CO2 and the heat coming from the sun. They also distribute this heat throughout the planet, making it pleasant to live on. But once they're gone, the temperatures will quickly jump to 250 degrees Fahrenheit and above. But even if we forget about the high temperatures, now we have no clouds, and they helped us too, by not letting through solar radiation. So we're also under the direct impact of the sun's rays. Our last hope is icebergs. Now that everything is terribly hot, they've melted. And maybe they'll be the last hope for humanity. But that cool solar flare was definitely worth it. Silly humans.
What would happen if our planet turned into two separate ones, one consisting entirely of land and the other one of water? Could we survive on any of them, and how? Well, you're lucky, because I'm going to answer this question right now. So let's imagine that our Earth has turned into two separate planets sharing one orbit. Let's call these hypothetical planets rock and water. I know, very original. Anyway, let's start with the rock, because this one is much easier to imagine. All we should do is ask, what would happen if all the oceans on the Earth suddenly dried up? Now, we know that water is life. It covers 70% of the surface of our planet. There's so much water that even if all the oceans and seas disappeared, some of it would still be left in underground rivers, streams, and so on. But unfortunately, it would not be enough for us to survive. All sea creatures disappear. After some time, all other animals, plants, and of course, people share their fate. Completely dried forests burst into flames sooner or later and burn until there is nothing left but ashes. But hey, it's not that bad. Well, it is bad, but life can still exist in some form. There are some bacteria that make cockroaches jealous. They're able to survive absolutely any conditions. For example, extremophiles have already evolved to live without water. These little guys can survive in an incredibly hot or acidic environment without water or even sunlight. Without them, the rock becomes an empty, lifeless planet. Although, who knows? Maybe someday extremophiles will be able to evolve into some wildly cool forms that can survive literally anywhere. But for now, the rock is just a floating rock, basically. Oh wait, did you imagine a hot desert or some sort of red-hot steppes? Surprise, surprise! This planet is actually extremely cold. You see, without water, there would be no atmosphere. The atmosphere consists of a concentration of various gases, including hydrogen and oxygen. Some H and O, you know where this is going, right? Yep, no water, no atmosphere. And since it is the atmosphere that accumulates all the heat we need, the planet would be very cold without it. The contrast between cold and less cold places also becomes very sharp. You see, water is basically a climate stabilizer. The oceans absorb almost all of the heat of our sun. They distribute it evenly over the Earth to make sure it doesn't get too cold or too hot. So without it, the rock gradually turns into a cold desert. The average temperature on this planet is around minus 100 degrees Fahrenheit. At both poles, the temperature is extremely low, about minus 300 degrees. And even in the warmest places, it doesn't exceed 20 degrees. These warm places are now the former oceans, because their dried-up depths are located much closer to the hot core of the planet. Wait, I hope you don't imagine this planet as covered in snow either. We don't have any water at all, remember? It's just a very cold rock. At this point, we're just a bigger and browner version of the moon. The moon is basically a waterless piece of Earth, after all. But hey, what happens to volcanoes? They're basically our last hope to stay warm, aren't they? Unfortunately, volcanic activity is decreasing due to a lack of water. You see, volcanoes and their eruptions happen because of the collisions of two tectonic plates, the oceanic and continental ones. The weight of the water presses on the oceanic plates. They go under the continental plates and form volcanoes. So if there's no water weight, then there's no volcanoes and volcanic activity drops significantly. The rock now is just a planet full of many incredible high mountains. And every time the tectonic plates collide, they form more and more of these mountains and trenches, including some very big ones, like the famous Mariana Trench. I would say, be careful not to fall, but hey, there's no one to fall there. So? Also, there's no weather anymore. No water means no more snow, ice, or rain, or even clouds. The wind would probably be quite strong, though. Well, that's the fate of the planet rock. Not very bright, so let's just go see how the water planet is doing. Many, many billions of years ago, I wasn't around then, our Earth actually was a planet entirely covered with water. Then, about 1 billion years ago, the sea level dropped, the land appeared. This has changed the atmosphere of our planet forever, and that's how life was born here. But what happens if it returns to its original state? Well, to answer that question, we should first learn more about the ocean planets. So, what does one of these look like? Oh, sorry, I almost forgot. We have no idea. We haven't found any planets of this type because they're incredibly rare. I mean, there is one planet that is low-key and could be called an ocean planet. Yeah, I'm not even going to try and pronounce that. Still, even this one doesn't look the way you probably imagine. The water on it is in a very weird, unique state. Scientists have called this hot ice or super liquid water, and we've never seen anything like this before. In general, though, the actual ocean planets are very hard to find due to many physical reasons. These planets require very specific temperatures, pressures, and so on. But alright, just hypothetically, what would such a planet look like? Well, first of all, of course, it cannot be made entirely of water. I hope you didn't actually think that there could be just some gigantic water blob spinning around a star. It should still be a planet with a core and some kind of foundation. So let's just imagine that all the water on the former Earth has mixed into one giant salty ocean. Wow, that would be a dream come true for the sea creatures, but not for the rest of us. The only animals that could survive in this situation, except fish, are probably the birds that can swim and feed on fish. Now, I think even if the sea level rose significantly, at least a couple of islets could still stay above the water. Such islands would be the former peaks of huge mountains like Mount Everest. So if these birds build their nests there, they can even survive for some time. But what about you and me? Well, we still have a chance. If we had enough time to prepare for the huge flood, we could stay safe either in giant submarines or on giant ships. We can grow food on board and fish from the ocean. But without the Everest Islands, we are unlikely to last long. If something breaks and we have nowhere to dock, we won't be able to fix it. Unfortunately, we no longer have drinking water. Now we can get it only from rain or by filtering seawater. But we have to store it someplace, right? And all these water containers would take up a lot of space and be very heavy. But in general, planet water is not as bad as it might seem. It's quite warm. The average temperature here is about 50 degrees Fahrenheit. And the gap between the lowest and highest temperatures is minimal, from minus 20 degrees at the poles to 70 degrees at the equator. Compared to planet rock, this ain't bad at all. Planet water would also be slightly larger than the Earth in radius due to the volume of, yes, water. The density of this planet would be, on the contrary, quite low. The gravity could become a bit weaker, too. Now, as for both planets, if we place them in the Earth's orbit, after some time, they would still move away from each other and follow different trajectories. They would have aligned themselves not to collide with each other. On one of them, the year would last 12 months, and on the other one, 10 or 11. And that's about it. A fun fact, all of this can actually happen in the future. First of all, the Earth's crust is gradually becoming thinner. Hey, I like thin crust. On my pizza. On my planet, not so much. So, one day, water can really flood our entire land. On the other hand, in a couple of billion years, when our sun begins to expand and turn into a red giant, all the oceans on our planet will really dry up. Alright, take a deep breath and shake it out. That's enough of this grim fairy tale. It's a waste of time to worry about such things so far off when, today, I can't find my wallet anywhere. I thought I put it over here. You're in the middle of the Sahara. You see a huge awning with a red target pattern. Its surface is so hot you could fry food on it. A drop of water is to hit the center of this target at the speed of light. Theoretically and technically, this experiment is impossible to conduct. But if it happens, then mysterious nothing awaits us. And each version of this nothing will be different. So we'll do 3 drops. Option 1. It's better to do it from a great height or space. You take off on a jetpack into the stratosphere. You have a bottle of water in your hand. You pour out one drop. Let's say it starts accelerating itself. In this case, even at a low speed, a drop of water will burn up in the protective layers of the atmosphere. In less than a second, the drop will turn to vapor. Let's say our planet had no such protection as the atmosphere. The air resistance would still get rid of the drop. The drop is flying down at a tremendous speed. The cold wind turns it into an icicle. The greater the drop velocity is, the stronger the air resistance is. The drop is moving faster and faster, soon reaching the speed of sound. Then, it just smashes into thousands of small particles. Under such conditions, the drop will never be able to reach the Earth at the speed of light. Nothing happens because nothing gets to the target. The next attempt involves changing the drop. Oxygen, carbon dioxide, ozone, and other gases in the atmosphere destroy any falling object. But what if the drop didn't meet all these obstacles? You change the internal structure of water chemically. So, you put your jetpack on again and grab a bottle of water. At the height of the Earth's orbit, you open it and pour out one drop. It accelerates and there's no resistance. It passes through the hottest layers of the atmosphere, but doesn't burn, passing the freezing temperature, but doesn't freeze up. It flies to the ground, developing the speed of light, and crashes again. But nothing happens. The drop got the properties of a light particle, a photon. It's only under such condition that it might develop the speed we need. No object with mass, be it a car, a house, a tree, an ant, a single air, a grain of sand, or a molecule, can reach the speed of light. Only light particles are capable of it since they don't have mass. An intangible drop falls into the center of the target, and again, nothing happens. The third option. Scientists found a way to accelerate a drop to the required speed. They also have to change the molecular composition of water, making it more resistant to high and low temperatures. To make the drop reach the speed of light without any damage, you need to place it in a perfect vacuum. No air resistance, no protective layers of the atmosphere. We leave only space and the water. For this purpose, scientists need to build a long pipe. In the center of the Sahara, around the same target, people create a scientific center. From here, the pipe should go up. Its height is approximately the distance to the International Space Station. That's 254 miles, which is about the height of 50 Everest mountains. You can't connect to the ISS itself as it's moving all the time. It revolves around the Earth, completing one revolution in 90 minutes. That's why astrophysicists and engineers should build a small station designed for one person. And this station should move parallel to a single point on the ground. The vacuum tube is made of solid stainless materials so that rain and high temperature couldn't destroy it. Inside, it's an alloy of titanium and graphene, the most durable metal on Earth. The pipe is built horizontally. Then, with the help of several helicopters and cables, it's placed in an upright position and attached to a small space station. The pipe is equipped with small pumps that pump the air out and block its flow inside. The water drop shouldn't touch the walls, so there's a special layer of gravity plates. They push the water away from the pipe surface, using the power of magnetism and sound waves. You put on a jetpack and fly to the station with a bottle of upgraded durable water. Your hands are shaking with excitement. Your breathing sounds loud in the spacesuit. You open the bottle, tilt it slightly, and pour one drop into a special box. Inside this container, the drop gets charged with the energy needed to develop the speed of light. Now it's ready for the journey. You look at the box, close your eyes, and press the start button. The drop flies into the pipe at a great speed. From the powerful blast wave, the entire station is thrown to the side. The drop accelerates, and at this point, the pipe made of the strongest metals on Earth begins to melt like ice cream. There's so much energy in the water now that it would be enough to provide electricity to a small city. And now the drop reaches the speed of light, which is 186,000 miles per second. The pipe turns to dust. It doesn't matter whether the drop hits the ground or not, because there will be nothing. Literally, all material objects, cars, houses, fields, oceans, computers, planes, ships, flowers, trees, should I go on, will disappear. Intangible things, such as gas, air, radio waves, electromagnetic radiation, billions of terabytes of digital information, all this will also be gone. Boy, are you in trouble. Any sound, shouting, music, the phone ringing, will be impossible to create and hear. The light will disappear, and then there will be complete darkness. But let's rewind time and see exactly what happened right now. It won't work, though, because there's no time either. Imagine time as a stormy river that flows rapidly in one direction. Then this river falls into an endless pit and disappears completely. All this happened because a drop of water crashed into our planet at the speed of light. As soon as a drop begins to approach the needed speed, it loses its properties of water. It's now the most powerful and heaviest object in the universe. The energy that comes from it destroys everything for hundreds of thousands of miles. Concrete, ground, rocks, etc., and on and on and on. Everything disappears. In the first second, it all gets shattered into millions of tiny pieces. Then these pieces are torn apart into millions of even smaller particles. The molecules burn up. Imagine a paper map of the world. If you wet it and tear it, it will turn into wet paper scraps. If you burn it, then part of the map will turn to ashes, and the other part will simply fly into the air in the form of smoke. The map will remain, but it will never look the same. But if you destroy the map's molecules, it's safe to say that the map never existed. There's no trace of its existence. The same thing happens to our planet. The energy coming from a drop of water makes the Earth never exist in space. And now the drop exceeds the speed of light. A black hole starts evolving. It expands and absorbs all the space debris. Then the Moon. Soon it will be the turn of Mars and all the other planets in our solar system. The black hole expands and increases the force of gravity inside it. Together with our planet, it absorbs light. It's getting closer and closer to the Sun. Our star splits into strips of light as if it had passed through a huge cosmic shredder. The Sun explodes and spits out an impossible amount of energy. It's believed that black holes appear after the explosion of stars. Right now, all the solar energy is being absorbed by our black hole. It's getting pitch black. The light from distant stars falls directly into the supermassive infinity. Meteorites flying within a radius of hundreds of thousands of miles around are also devoured into the unknown. There are many black holes in space, but only one of them was created by a small drop of water. The higher the speed of any object, the heavier it gets. Mass is the amount of energy that an object has. When water molecules reach the speed of light, their mass begins to grow, and there are no limits to this. It becomes infinite. An infinite mass forms a black hole. It absorbs everything, and nobody knows what's inside the black hole. All that remains is darkness and the unimaginable force of gravity. So I'm guessing here that we probably